સેમિકન્ડક્ટર શું છે એ સમજીશું. તો સૌપ્રથમ ફરીથી એકવાર ઉદ્યોગ સાહસિકતા વિકાસ સંસ્થાન તરફથી આપ સર્વેનું હાર્દિક સ્વાગત કરું છું અને તાળીઓના ગડગડાટથી આપણો પ્રોગ્રામની શરૂઆત આપણે કરીએ. મિત્રો, આપ સૌ જાણો છો, રિસેન્ટલી થોડા સમયની અંદર સેમિકન્ડક્ટર ઇન્ડસ્ટ્રીઝ વિશે આપણે ઘણું બધું સાંભળીએ છીએ. 19મી જુલાઈ 2024ના રોજ માનનીય પ્રધાનમંત્રી સાહેબના અધ્યક્ષતામાં સેમી કોન્ફરન્સ આપણે મહાત્મા મંદિર ખાતે યોજાઈ હતી, જેમાં ગુજરાતના, ઇન્ડિયાના અને ગ્લોબલ ક્ષેત્રના ઘણા બધા એક્સપર્ટ્સ, ફેકલ્ટીઝ, ઇન્ડસ્ટ્રી સ્પેશિયાલિસ્ટ એ કોન્ફરન્સમાં હાજર રહેલા હતા. અને ગુજરાત સરકાર અને ભારત સરકારનું જે ઇન્ડિયન સેમિકન્ડક્ટર મિશન જે છે, જે 2021માં જે માનનીય પ્રધાનમંત્રી શ્રી નરેન્દ્રભાઈ મોદી સાહેબ, જે આપણા દીર્ઘદ્રષ્ટા વડાપ્રધાન છે, તેઓએ વિઝન રાખ્યું હતું સેમિકન્ડક્ટરનું. અને આપ સૌ જાણો છો, વિકસિત ગુજરાતથી વિકસિત ભારત 2047 અને આત્મનિર્ભર એ જે આપણી મુખ્ય એક નેમ છે, એ અચીવ કરવાના ભાગરૂપે સરકારશ્રી દ્વારા વિવિધ ઇનિશિયેટિવ્સ, અમલીકરણ અને વિવિધ સ્કીમોની યોજનાઓનું આપણે બહુ સરસ રીતે સફળતાપૂર્વક એનું સંચાલન પણ કરીએ છીએ, અમલીકરણ પણ કરીએ છીએ અને સરકારી વિભાગ દ્વારા. તો એના જ ભાગરૂપે અને ઉદ્યોગ અને ખાણ વિભાગ અમારો જે છે ગાંધીનગર ખાતેથી, તો ઉદ્યોગ સાહસિકતા સંસ્થાન દ્વારા આજે આ એક દિવસીય સેમિનારનું આયોજન એટલા માટે જ કર્યું હતું કે આપણે સૌ સેમિકન્ડક્ટર વિશે જાણીએ. સેમિકન્ડક્ટર શું છે, સેમિકન્ડક્ટરની અંદર હાલમાં વિવિધ ઉદ્યોગ ધંધા અંગેની તકો શું છે, માર્કેટ શું છે. તમે લોકોએ રિસેન્ટલી પણ જાણ્યું હશે કે સૂચિ સેમિકોન કરીને એક ઇન્ડસ્ટ્રી જે સ્થાપિત થઈ છે હાલમાં જ સેમિકન્ડક્ટર ક્ષેત્રે. માઇક્રોન આવી રહી છે, બરાબર, ટાટા ઇલેક્ટ્રોનિક્સ છે. આવી સારી કંપનીઓ સાણંદ ખાતે, ધોલેરા ખાતે પોતાનો પ્લાન્ટ નાખવા જઈ રહ્યા છે. તો આની અંદર આપણી પાસે વિપુલ પ્રમાણમાં તક છે અને ગુજરાત એમાં એકદમ આગળ નંબર 1ની હરોળનું એક ઉભરી આવ્યું છે. તો આપણે એનો ફાયદો લઈએ. તો આપણે શરૂઆત કરીએ પ્રોગ્રામની. તો સૌપ્રથમ તો આ પ્રોગ્રામના આજના મુખ્ય મહેમાન અને આજના આપણા અતિથિ અને અમારા જે એક્સપર્ટ્સ, જે તમને આ આખા કાર્યક્રમ દરમિયાન સેમિકન્ડક્ટર ક્ષેત્રનું વિવિધ આપણે યોજનાઓ અને સેમિકન્ડક્ટર શું છે એની જાણકારી આપશે. તો એવા અમારા આજના એક્સપર્ટ ફેકલ્ટી પર હાર્દિક સ્વાગત કરું છું. સૌપ્રથમ તો અમારા CEDના ઉદ્યોગ સાહસિકતા વિકાસ સંસ્થાનના નિયામક શ્રી ડોક્ટર નીલકુમાર શિવાણી સાહેબનું હું હાર્દિક સ્વાગત કરું છું. સર, સ્ટેજ પર આવે એટલે ગાડીઓથી સ્વાગત કરીએ. આજના સપ્તર્ષિ એકેડમી આપને જણાવતા ખૂબ જ આનંદની લાગણી અનુભવું છું કે ઉદ્યોગ સાહસિકતા વિકાસ સંસ્થાન એ આજે સપ્તર્ષિ એકેડમી કે જે અમદાવાદમાં જ ખાતે સ્થિત છે અને સેમિકન્ડક્ટર ક્ષેત્રે વિવિધ પ્રકારની પ્રેક્ટિકલ ટ્રેનિંગ, થિયરેટિકલ ટ્રેનિંગ અને ખૂબ જ સારું એવું માર્ગદર્શન પૂરું પાડે છે. છેલ્લા 4 વર્ષથી કાર્યરત છે. અને સપ્તર્ષિ એકેડમીના જે ડાયરેક્ટર સાહેબ છે પિનાકી ઠાકર સાહેબ, એનું હાર્દિક સ્વાગત કરું છું. સ્ટેજ પર આવે પિનાકી ઠાકર સાહેબ, કે જેઓ ઇસરોના એક સિનિયર સાયન્ટિસ્ટ છે અને 35થી 40 વર્ષનો બહોળો અનુભવ ધરાવે છે આ ક્ષેત્રમાં. અને આજનો આ જે સેમિનાર છે એમાં એક્સપર્ટ સેશન તરીકે અને નોલેજ પાર્ટનર તરીકે સપ્તર્ષિ એકેડમી આપણી સાથે જોડાયેલું છે. તો એકવાર એમનો ફરીથી તાળીઓથી સ્વાગત થઈ જાય. આજના આ સેમિકન્ડક્ટર વર્કશોપના ભાગરૂપે એક્સપર્ટ તરીકે બીજા આપણા પાસે ઉપસ્થિત છે સુધીર નાયક સાહેબ, કે જેઓ ઇન્ફો ચિપ્સના કો-ફાઉન્ડર છે, જેઓ 35થી 40 વર્ષનો અનુભવ ધરાવે છે. સર, તો ખૂબ તાળીઓથી સ્વાગત કરીએ આપણે. ઉપરાંત અમારા અમદાવાદ ઓફિસ જિલ્લા ઉદ્યોગ કેન્દ્ર, જે હમણાં શરૂઆતમાં વાત કરી કે અમારા ઉદ્યોગ અને ખાણ વિભાગની ઉદ્યોગ કમિશનર દ્વારા જે વિવિધ સ્કીમોનું અમલીકરણ થાય છે, તો જિલ્લા ઉદ્યોગ કેન્દ્ર ખૂબ જ સારી કામગીરી કરી રહ્યું છે બચત ભવન ખાતેથી. તો જિલ્લા ઉદ્યોગ કેન્દ્રના પણ પટિયાર સાહેબ અહીંયા હાજર છે. તો એમને પણ હું સ્ટેજ પર આમંત્રિત કરવા માંગીશ. પટિયાર સાહેબ, પ્લીઝ. ખૂબ આભાર. પ્રોગ્રામને આગળ ધપાવતા આપણી ભારતીય પરંપરા પ્રમાણે સ્ટેજ પર ઉપસ્થિત સર્વે મહાનુભાવોનું ખૂબ સ્વાગત છે, ખૂબ હાર્દિક સ્વાગત છે. અને પ્રોગ્રામની શરૂઆત કરતા આપણે પરંપરા અનુસાર, સંસ્કૃતિ પ્રમાણે આપણે દીપ પ્રાગટ્યથી શરૂઆત કરીએ. તો હું દરેક મહાનુભાવોને સ્ટેજ ઉપરથી વિનંતી કરીશ કે દીપ પ્રાગટ્ય માટે આગળ આવે. પ્લીઝ સર. Please, sir. તમામ મહાનુભાવોનું ખૂબ ખૂબ ધન્યવાદ. હવે દીપ પ્રાગટ્ય પછી આજના મંચ પર ઉપસ્થિત તમામ મહાનુભાવોનું આપણે ફૂલ નહીં તો ફૂલની પાકડી એવી રીતે સીઈડી તરફથી ઉદ્યોગ સાહસિકતા વિકાસ સંસ્થાન તરફથી આપણે દરેક મહાનુભાવોનું સ્વાગત કરીશું. આપણે તો સૌપ્રથમ આજના જે આપણા એક્સપર્ટ છે, એક્સપર્ટ ફેકલ્ટી, ત્યાંથી શરૂઆત કરીએ. આજે સપ્તર્ષિ એકેડમી, આપણે જે વાત કરી શરૂઆતમાં પણ, ઉદ્યોગ સાહસિકતા વિકાસ સંસ્થાન સપ્તર્ષિ એકેડમી સાથે મળીને સેમિકન્ડક્ટર ક્ષેત્રે ઘણા બધા તાલીમ કાર્યક્રમ, સેમિનાર કરવાનું આયોજન છે. એના ભાગરૂપે આ પહેલો જ સેમિનાર ખૂબ જ સફળતાપૂર્વક શરૂ થયેલ છે. આજે નહીં તો 225થી વધુ પાર્ટિસિપન્ટ્સ આ સેમિનારમાં ભાગ લઈ રહેલ છે. આ ઓડિટોરિયમ હોલમાં, એના ઉપરાંત આપણા બીજા 2 ક્લાસરૂમ છે, ત્યાં આ પ્રોગ્રામનું લાઈવ સ્ટ્રીમિંગ થઈ રહ્યું છે. તો ખૂબ ખૂબ આનંદની લાગણી અનુભવીએ છીએ. તો સૌપ્રથમ તો આજના આપણા એક્સપર્ટ સપ્તર્ષિ એકેડમીના ડાયરેક્ટર અને એક્સ ઇસરો સાયન્ટિસ્ટ પિનાકિન ઠાકર સાહેબને જે સ્વાગત છે, કિયામુદ્દીનજી છે અમારા મેનેજ સ્કિલ, એમને વિનંતી કરીશ કે પિનાકિન ઠાકર સાહેબનું બુકેથી સ્વાગત કરશે. હું સંદીપ પટેલજીને અમારા કેમ્પસ ઓફિસરને વિનંતી કરીશ કે પિનાકિન ઠાકર સાહેબનું બુકથી સ્વાગત કરે, પુસ્તકથી સ્વાગત કરે. સંદીપ પટેલ. આજે ઉપસ્થિત શ્રી સુધીર નાયક સાહેબ, કો ફાઉન્ડર જે ઇન્ફોચિપ્સના છે. હું કિયામુદ્દીનજીને ફરીથી એક સ્વાગત કરું છું. એમનું વિનંતી કરું છું કે બુકી અને બુકથી સુધીર નાયક સાહેબનું સ્વાગત કરે. આપણે જણાવતા ખૂબ જ આનંદ થાય છે કે અહીંયા અમારા ઘણા બધા સીઈડીના એન્ટરપ્રિન્યોર ઉપલબ્ધ છે. આ પ્રોગ્રામ કે જેઓનું ટર્નઓવર મિનિમમ 5 કરોડથી માંડીને 20 કરોડ સુધીનું ટર્નઓવર ધરાવે છે અને છેલ્લા 8 થી 10 વર્ષથી ખૂબ જ સફળતાપૂર્વક પોતાનો બિઝનેસ રન કરે છે. જેઓ અહીંયા ક્યાંક ને ક્યાંક અમારા અમદાવાદ સેન્ટર, નરોડા સેન્ટર કે ગુજરાતના અલગ અલગ જે અમારા ટ્રેનિંગ સેન્ટર છે ત્યાંથી તાલીમ લઈને પોતાનો ઉદ્યોગ ધંધો શરૂ કરેલ છે અને ખૂબ જ સફળતાપૂર્વક આ પ્રોગ્રામ જે બિઝનેસ છે એમનો એ રન કરી રહ્યા છે. તો અમારા ઉદ્યોગ સાહસિકતા વિકાસ સંસ્થાનના ડાયનામિક ડાયરેક્ટર ડોક્ટર નીલકુમાર શિમાળી સર હાજર છે, જેઓની પ્રેરણા અને પ્રોત્સાહનથી અમે આ એક પ્રોગ્રામનું આયોજન કર્યું છે. એમનું પણ એક સૂચન હતું કે આવો કંઈક જે આપણે ઇમર્જિંગ ટ્રેન્ડ છે, જે સેમિકન્ડક્ટર છે, VLSI છે, પછી ડિજિટલ માર્કેટિંગ છે, ગ્રીન ઇકોનોમી છે, ગ્રીન મેન્યુફેક્ચરિંગ પ્રેક્ટિસ છે, તો આવા પ્રકારના સબ્જેક્ટ્સને ફોકસ કરીને જે સસ્ટેનેબલ ડેવલપમેન્ટનું આપણું જે વિઝન છે, માનનીય પ્રધાનમંત્રી સાહેબનું વિઝન છે કે ભાઈ સસ્ટેનેબલ ડેવલપમેન્ટ થાય લોકોને એક ઇકો ફ્રેન્ડલી પ્રોડક્ટ મળે, ઇકો ફ્રેન્ડલી વાતાવરણ સર્જાય અને એ પ્રકારની જે મેન્યુફેક્ચરિંગ પ્રેક્ટિસ, બિઝનેસ પ્રેક્ટિસ ફેલાય. તો એવો સરનું જે નિયમ હતું અને એ જ મુજબ અમારા નિયામકશ્રી અમને ખૂબ જ આમાં પ્રોત્સાહિત કર્યા છે. તો એમનું સ્વાગત હું સંદીપભાઈ પટેલ અને અમારા જે વુમન આંતરપ્રિન્યોર છે નિશાબેન પટેલ, એમને હું વિનંતી કરીશ કે સરનું સ્વાગત કરે. ઓકે. અને ખૂબ ખૂબ આભાર. સ્વાગત વિધિ પૂરી થયા બાદ હવે આપણે આ પ્રોગ્રામના ટેકનિકલ રાઉન્ડમાં પ્રવેશ કરી રહ્યા છીએ. શરૂઆતમાં જ મેં વાત કરી એ પ્રમાણે કે ગુજરાત એ કહેવાય ને કે પ્રાઇમરી સેમિકન્ડક્ટર સેન્ટરનું એક હબ છે, જે 2021માં માનનીય પ્રધાનમંત્રી સાહેબે જે ઇન્ડિયન સેમિકન્ડક્ટર મિશન જે લોન્ચ કર્યું હતું, એના ભાગરૂપે 2022માં આખા ભારતની અંદર પહેલું સ્ટેટ ગુજરાત જ છે કે જેણે સેમિકન્ડક્ટર પોલિસી લોન્ચ કરી છે, જે આપણા માટે ગર્વની વાત છે. આમાં તાળીઓ થઈ જાય આપણે. અને રિસેન્ટલી જે સૂચિ સેમિકોન કરીને જે પ્લાન્ટ સ્થાપિત થયો છે, એના ઉપરાંત પણ માઇક્રોન છે, ટાટા છે, પછી મુરુગપ્પા ગ્રુપનું જે સીજી એન્ટરપ્રાઇઝ છે, તો એ લોકો પણ સેમિકન્ડક્ટર ક્ષેત્રમાં આવી રહ્યા છે. સાણંદ ખાતે, ધોલેરા ખાતે, વડોદરા ખાતે તમને કદાચ ખ્યાલ હશે કે એરોસ્પેસ પોલિસી પણ અમલમાં છે. અને વડોદરા ખાતે આપણું એરબસનું એક સેન્ટર પણ શરૂ કર્યું છે ટાટા સાથે કોલેબોરેશનમાં. તો ખૂબ જ સુંદર મજાનું આયોજન થયેલું છે. સારા સારા બિઝનેસ પ્રેક્ટિસીસ, સારા સારા સસ્ટેનેબલ ડેવલપમેન્ટ થઈ રહ્યા છે. તો આ સેમિકન્ડક્ટર ઇન્ડસ્ટ્રીઝ પણ ખૂબ જ એકદમ ઇમર્જિંગ છે. ખૂબ જ અત્યારે એમાં બિઝનેસ ઓપોર્ચ્યુનિટીની તકો પણ બહુ વિપુલ પ્રમાણમાં છે. તો ટેકનિકલ સેશનની અંદર આપણે આપણા એક્સપર્ટ તરફથી એ જોઈશું કે આનો મહત્તમ લાભ આજના એન્ટરપ્રિન્યોર છે, ફર્સ્ટ જનરેશન એન્ટરપ્રિન્યોર છે, એસ્પિરન્ટ્સ છે, અત્યારે હાજર જે ઇલેક્ટ્રિકલ એન્જિનિયરિંગ બ્રાન્ચ, ઇન્સ્ટ્રુમેન્ટેશન બ્રાન્ચના જે વિદ્યાર્થીઓ છે, તો એ પણ આનો લાભ કેવી રીતે લઈ શકે એ આજે જાણીશું. તો સૌપ્રથમ તો ટેકનિકલ રાઉન્ડની શરૂઆત કરતા પહેલા ઉદ્યોગ સાહસિકતા વિકાસ સંસ્થાનના અમારા નિયામક શ્રી ડોક્ટર નીલકુમાર શિમાલી સાહેબનું હું સ્વાગત કરીશ કે સર પ્રાસંગિક પ્રવચન કરે. પ્લીઝ.
સર્વેને નમસ્કાર. સૌપ્રથમ તો મંચ પર ઉપસ્થિત સપ્તર્ષિ ડાયરેક્ટર, સપ્તર્ષિ નિગમના જે પિનાકી ઠાકર સાહેબ છે, સુધીર નાયક સાહેબ ઇન્ફોચિપના કો ફાઉન્ડર છે, સાકરચંદ યુનિવર્સિટીના વીસી, અને અહીંયા પોતાનો કિંમતી સમય કાઢી અને અહીંયા સેમિનાર વર્કશોપ જે સેમિકન્ડક્ટર માટે ઉપસ્થિત થઈ રહેલા સેમિકન્ડક્ટર વિષયના તજજ્ઞો, નિષ્ણાંતો, કામકર્તાઓ અને મારા યુવા મિત્રો, સૌપ્રથમ તો ગુજરાત સરકાર વતી આપ સૌ સમય કાઢીને આ સેમિનાર વર્કશોપમાં ભાગ લેવા આવ્યા એ બદલ હું આપનો હૃદયથી આભાર માનું છું અને આપને અભિનંદન પણ આપું છું કે આપે અહીંયા આવવાની, સમય કાઢીને અહીંયા આવ્યા, એનો મતલબ તમારી અંદર એવી ઈચ્છા છે કે આ ક્ષેત્રની અંદર તમે કંઈક કામ કરીને સ્વરોજગાર શરૂ કરી શકો છો, અથવા તો તાલીમ લઈને ત્યાં કંઈ જોબ ગીવર અથવા જોબ સિકર બની શકો છો. તમારી અંદર એ ઈચ્છા છે અને એનાથી તના લીધેથી પ્રેરણા થઈને તમે અહીંયા આવ્યા છો, એ માટે તમારો હું આભાર માનું છું. આજનો વિષય છે સેમિકન્ડક્ટર ક્ષેત્રમાં, જે મારા ડેપ્યુટી ડાયરેક્ટર ધર્મેન્દ્ર પંડ્યાએ જેમ જણાવ્યું કે ઘણી બધી કંપનીઓ અત્યારે ગુજરાતમાં આવી રહી છે. માઇક્રોન જે છે એ પોતાનું ઉત્પાદન હમણાં ડિસેમ્બરમાં ચાલુ કરી દેવાના છે. એના કારણે બીજી ઘણી બધી તકો ઉપસ્થિત થવાની છે. એને આનુષંગિક ઘણી બધી કંપનીઓ છે એ ચાલુ થશે. એનું એસેમ્બલિંગ વર્ક કરવાનું, આપણે જો હમણાં જ સમાચાર વાંચ્યા હોય તો સુરતમાં જે એસેમ્બલિંગનો આઉટસોર્સિંગનો પહેલો પ્લાન્ટ છે એનું ઉદ્ઘાટન કરવામાં આવ્યું. તો આવા તો ઘણી બધી તકો સેમિકન્ડક્ટર વિષયમાં આવવાની છે. આ વિષય ટેકનિકલ છે. સંજોગથી હું પણ આ ઇલેક્ટ્રોનિક્સ ઇન્ડસ્ટ્રીઝથી જ બિલોંગ કરું છું. મેં પણ પીએચડી ઇલેક્ટ્રોનિક્સમાં જ કર્યું છે, પરંતુ એના માટે અહીંયા ઘણા બધા સબ્જેક્ટ એક્સપર્ટ આપણે બોલાવ્યા છે. ઇસરોના ડાયરેક્ટર દેસાઈ સાહેબ છે, જે પણ આપણને માર્ગદર્શન આપવાના છે. પિનાકી ઠાકર સાહેબ અને સુધીર નાયક સાહેબ, એ 3 જણા આપણને આમાં કેટલું તકો ઓપન છે, શું ઓપોર્ચ્યુનિટી ઊભી થશે, કયા પ્રકારની નીતિ છે ગુજરાત સરકાર અને ભારત સરકાર તરફથી, તમને કયા પ્રકારની સહાયતા મળી શકે, એ પણ વિસ્તૃત પરિચય આપશે. હું અત્યારે CED ના માધ્યમથી ફક્ત CED નો પરિચય આપીને મારું જે સ્પીચ છે એનો સમય ઘટાડી અને તમને વધારે ને વધારે જે આપણે એક્સપર્ટને બોલાયા છે એનો લાભ મળે એનું કહીશ. તો આપણે જે અહીંયા બેઠા છે એ સંસ્થા છે CED, સેન્ટર ફોર એન્ટરપ્રેન્યોરશિપ ડેવલપમેન્ટ. આ સંસ્થાની સ્થાપના ગુજરાત સરકાર દ્વારા 1979માં ઉદ્યોગ સાહસિકતાને પ્રોત્સાહન આપવા માટે, કારણ કે સરકાર છે તમામને રોજગારી નથી આપી શકવાની, બધાને સરકારી નોકરી નથી મળી શકવાની. તો ગુજરાતના યુવાનો જેના લોહીમાં છે કે ઉદ્યોગ સાહસિકતા, એ પોતાનો ઉદ્યોગ, ગુજરાતની ઉદ્યોગ સાહસિકતા, ગુજરાતને તો કહેવામાં છે કે આ વેપારીઓનું રાજ્ય છે, અહીંયા સૌથી વધુ વેપાર ધંધા ફૂલાફાલા છે. તો વધુ ને વધુ લોકો પોતાનો સ્વરોજગાર ચાલુ કરે, પોતે રોજગારી મેળવે અને બીજાને પણ રોજગારી આપે, એના થકીના પ્રયત્નો માટે ગુજરાત સરકારે CED ની સ્થાપના કરી હતી. અને ગુજરાત માનનીય પ્રધાનમંત્રીશ્રીનું વિઝન છે કે 2047 સુધીમાં ભારત વિકસિત ભારત બને, ગુજરાત પણ એમાં કન્ટ્રીબ્યુટ કરે અને આપણે વિશ્વની 3જા નંબરની અર્થવ્યવસ્થા બનીએ. વિશ્વની 3જા નંબરની અર્થવ્યવસ્થા બનવું હશે તો આપણે જેટલી તકો આપણે ઉભી રહી, વધુ ને વધુ સ્વરોજગાર ચાલુ કરવા પડશે. સરકાર તમામને રોજગાર નથી આપી શકતી, પરંતુ સરકાર એના ગુજરાત સરકારે તમામ માટે વાતાવરણ પૂરું પાડે છે. આપણે જોતા હશો તો વાઇબ્રન્ટ સમિટના માધ્યમથી ગુજરાત સરકાર ઘણા બધા ઉદ્યોગોને આપણે ત્યાં ગુજરાતમાં સ્થાપવા માટે પ્રેરે છે. CED જેવી સંસ્થાના માધ્યમથી અમે તાલીમ આપીએ છીએ કે ઉદ્યોગ ધંધો કેવી રીતે શરૂ કરવો, કારણ કે ઉદ્યોગ ધંધો શરૂ કરવાનું તો નક્કી કરી દઈએ કે કરી નાખે. દાખલા તરીકે કોઈ એક ધંધો ચાલતો હોય, આમાં હું વચ્ચે પહેલા આણંદ જિલ્લામાં હતો તો ત્યાં પાપડ ઉદ્યોગ વધારે ચાલે, તો એક જણે નક્કી કર્યું કે ભાઈ નડિયાદના ઉત્તરસંડના પાપડ વખણાય, બધાએ પાપડનો ઉદ્યોગ શરૂ કરી નાખ્યો, લોન લઈ લે બેંકમાંથી, ધંધો શરૂ કરે, પોતાનો કિંમતી સમય, તમે તમારા પરિવારનો સમય જ્યારે ધંધો શરૂ કરો છો તો તમારા પરિવારને જે સમય આપવાનો હોય એ તમે એને આપો છો. તમારી જે મૂડી હોય, જે બચત હોય, એ બચતને તમે ધંધામાં લગાડો છો. પછી તમે એના માટેને ઘણી બધી જે તમારા જીવનની માણવાની તકો હોય, તહેવાર હોય, લગ્ન હોય, એ બધાનું બલિદાન આપીને ધંધો કરો છો. પરંતુ જો એ ધંધોમાં છેવટે તમે નિષ્ફળ જાઓ તો તમારે જે બેંકમાંથી લોન લીધી હોય કે લીધું હોય એ બધુંની પણ તમને તકલીફ પડે. તો એ વખતે બધા ચાલુ કરી દીધા, પણ એટલા બધા વાયેબલ થયા નહીં. વાયેબલ ના થયા એટલે એ લોકોએ જે ઘણીવાર જે રો મટીરિયલ લીધું હોય, ચણાનો લોટ, બીજા મશીનો, એ ચૂકવવાના પણ તકલીફ પડે. ગુજરાત સરકાર CED ના માધ્યમથી તમને શીખવાડવા માંગે છે કે તમે ધંધો શરૂ કરો તો એના માટે શું જોઈએ. તો એના માટે સૌથી પ્રથમ તમારે આયોજન કરવું પડે. તો એના માટેની જે ઉદ્યોગકારો હોય, એને ઉદ્યોગકાર બનવું હોય તો એને ઉદ્યોગ પહેલા પોતાનું સેલ્ફ અસેસમેન્ટ કરવું જોઈએ. હું કેવી રીતે ઉદ્યોગ ધંધો શરૂ કરીશ એના માટેનું માર્કેટ સ્ટડી કરવી પડે. આપ જે કોઈ ધંધો શરૂ કરવા માંગતા હોય એનું માર્કેટમાં કેટલી ઓપોર્ચ્યુનિટી છે, એના માટે કેટલા મૂડીરોકાણની જરૂર પડશે, એ મૂડીરોકાણ કરવા માટે મને સરકારની કઈ સંસ્થાઓ મદદ કરશે. આજના પ્રોગ્રામમાં આપણને સરકારની કઈ યોજનાઓમાંથી નાણાકીય લાભ, પ્રોત્સાહન અને સબસિડી મળી શકે છે એની પણ અમે વ્યવસ્થા કરી છે. અમારા જિલ્લા ઉદ્યોગ કેન્દ્ર અમદાવાદના મેનેજર શ્રી પઢિયાર સાહેબ છે, એ ગુજરાત સરકારની વિવિધ યોજનાઓ છે, વાજપેયી બેંકેબલ, પ્રાઇમ મિનિસ્ટર એમ્પ્લોયમેન્ટ જનરેશન પ્રોગ્રામ, આત્મનિર્ભર યોજના, આ બધામાં જો આપ સરકારની યોજનાનો લાભ લો અને ધંધો શરૂ કરવા માંગતા હોય તો 45 થી 50% જેટલી સબસિડીની રકમ, 25 લાખ સુધીનો જો પ્રોજેક્ટ હોય 30-40 લાખ સુધીનો, એમાં તમને 45% જેટલી સબસિડી ગુજરાત સરકારના માધ્યમથી મળી શકે છે. પરંતુ એ સબસિડી મળ્યા પછી એટલો જ મુદ્દો નથી, કારણ કે સબસિડીથી આપણે ધંધો નથી કરવાનો. ધંધો કર્યા પછી તમે એને માર્કેટિંગ ક્યાં કરશો, તમારે બેંક માટે લોન અપ્લાય કરવી હોય તો પ્રોજેક્ટ રિપોર્ટ કેવી રીતે તૈયાર કરશો, એ બધાની સ્ટડી, એ બધાનું નોલેજ તમને CED ના જે અમારા EDP1 અને EDP2 પ્રોગ્રામ ચાલે છે એ પ્રોગ્રામમાં તમને એની માહિતી આપવામાં આવે છે. તમે એનું માર્કેટિંગ કરશો, કયા રો મટીરિયલની જરૂર પડશે તો ક્યાંથી રો મટીરિયલ લાવશો, એના માટે પેકેજિંગની જરૂર પડશે તો પેકેજિંગ કયા પ્રકારનું કરશો. ગુજરાતમાં કે અહીંયા ડોમેસ્ટિકમાં જો તમને એટલી બધી તક ન હોય તો તમે બહાર કેવી રીતે કરશો. અમારા CED ના એક બેન છે અહીંયા નારાયણપુરામાં, એમનું છે, એમને અમારા CED માંથી તાલીમ લીધી હતી. એમણે ફૂડ એગ્રો પ્રોસેસિંગમાં પોતાનો ધંધો ચાલુ કર્યો છે. એની અંદર 30 જેટલી ખોરાકની આઈટમો બનાવે છે અને ખાખરા અને બીજી નમકીન એ એક્સપોર્ટ કરે છે. એમણે બહુ નાના પાયે શરૂ કર્યું હતું. આજે એ એમનું ટર્નઓવર અહીંયા અમદાવાદમાં નાનકડો ગૃહ ઉદ્યોગ છે, એમણે 10 જેટલી બહેનોને પોતાના ત્યાં રાખ્યા છે કામ માટે અને ઓલમોસ્ટ 2 થી 3 કરોડનું એમનું ટર્નઓવર છે. એવી જ રીતે અમારે ત્યાંથી એક સોલારના માટેના એક તાલીમાર્થી નીકળ્યા હતા અને એમણે પોતાનો સોલારનો ધંધો શરૂ કર્યો. એમણે અત્યારે પોતાની સાથે સાથે બીજા 42 લોકોને રોજગારી આપી છે. એટલે પોતે તો ધંધો શરૂ કર્યો, પોતે તો રોજગાર મેળવ્યો, બીજા 42 લોકોને રોજગાર આપ્યો છે એમાં. અને એ લોકો પણ સોલારમાં એક્સપોર્ટની કામગીરી કરે છે અને અહીંયા ડોમેસ્ટિક માર્કેટ પણ કરે. એમનું ટર્નઓવર 22 કરોડ જેવું થઈ ગયું. અમારા ત્યાંથી બીજા બેને તાલીમ લીધી હતી. આપણે જે આપણી હર્બલ ટી આવે ને, ગ્રીન ટી, એ ગ્રીન ટી આપણા પુરાણોમાં જે કોરોનામાં ટાઈમમાં આપણે જોયું હતું કે પેલો ઉકાળા બનાવીને આપણે પીતા હતા, જેનાથી આપણી સૂંઠ ને બધાથી આપણી ઇમ્યુન સિસ્ટમ બેટર થતી. એ બેને એનો અભ્યાસ કર્યો અને અલગ અલગ પ્રકારની ગ્રીન ટી બનાવી, હર્બલ ટી. આજે એ બેન એને એક્સપોર્ટ પણ કરે છે. તો આવી બધી તમારે પણ માર્કેટ, કોઈ પણ ધંધો શરૂ કરતા પહેલા એનું ઇનફ રિસર્ચ કરવું પડશે કે એની કેટલી તક છે. અત્યારે પુષ્કળ પ્રમાણમાં તક ઉત્પન્ન છે ઇલેક્ટ્રોનિક સેક્ટરની. જો જેના માટે આપણે સેમિનાર કર્યો છે, તો હમણાં જ અમારા ત્યાં એક સ્ટાર્ટઅપ આવ્યું હતું. એ સ્ટાર્ટઅપમાં એમને બેન્ડ બનાવ્યો છે. બેન્ડ આપણા કપાળમાં લગાવવાથી આપણા મગજને સ્કેન કરી અને એ વખતે આપણામાં કયા પ્રકારની આપણું મૂળ કયા પ્રકારનો છે એનું એનાલિસિસ કરતું સોફ્ટવેર બનાવ્યું છે. તો અત્યારે આઈઓટી, બ્લોકચેન એ બધામાં ઘણી તકો ઉપલબ્ધ છે. આપ એમનો ઉપયોગ કરી કોઈ પણ નવો ધંધો શરૂ કરી શકો છો. ગુજરાત સરકાર આપની તમામ સ્ટેજે મદદ કરવા તૈયાર છે. આપને ઉદ્યોગ ધંધો શરૂ કરવો હોય એના માટેનું તમામ માર્ગદર્શન CED આપશે. એકવાર આપને નક્કી કરી લો કે અમારે હવે ધંધો શરૂ કરવો છે, એના માટેની અન્ય જે અમારી જિલ્લા ઉદ્યોગ કેન્દ્રની સ્કીમો છે એના દ્વારા અમે તમે સબસિડીનું આપીશું. અમારું MSME કમિશનરેટ છે. આપ એકવાર ધંધો શરૂ કરી દો અને આપની પ્રોડક્ટને માર્કેટ કરવી હોય એના માટે પણ જે કંપનીઓમાં આપની પ્રોડક્ટને સપ્લાય કરી શકાતું હોય એનું હેન્ડહોલ્ડિંગ પણ ગુજરાત સરકારના માધ્યમથી કરવામાં આવે છે. આ CEDની જનરલ બાબતો છે જેને મેં આપને ધ્યાને મૂકી છે. અને આજનો જે ટોપિક છે સેમિકન્ડક્ટર માટેનું છે, એના માટેના તજજ્ઞો આપને આ સબ્જેક્ટમાં વિશેષ માર્ગદર્શન આપશે. તેથી આપને વધુ એમનો સમય મળી રહે એ ધ્યાને લઈ હું મારું વિરમું છું. ભારત માતા કી જય. વંદે માતરમ.
ખૂબ ખૂબ આભાર ડોક્ટર શિવાણી સાહેબ મોટિવેટ કરવા બદલ. સરે જે વાત કરી કે સેમિકન્ડક્ટર અને ઉપરાંત CEDની જે એક્ટિવિટી વિશે વાત કરી, તો આજનો એક જે આપણો એજન્ડા છે સેમિકન્ડક્ટર અને ઉપરાંત આની અંદર પણ તમારે કેવી રીતે બિઝનેસ કરવો, આ એક શરૂઆત છે. આજે આપણે એક વર્કશોપ રાખ્યો છે, સેમિનાર રાખ્યો છે, જેમાં તમને સેન્સિટાઇઝ કરવા માંગીએ છીએ કે સેમિકન્ડક્ટર ઇન્ડસ્ટ્રી શું છે. એની અંદર પણ ડિટેલમાં જે આપણા આજના નોલેજ પાર્ટનર છે સપ્તર્ષિ એકેડમી, એમની સાથે આપણે બેસીશું, વિચારણા કરીશું અને કેવા કેવા પ્રકારના અભ્યાસક્રમ બની શકે ટેકનો EDP ઇન સેમિકન્ડક્ટર, તો એ પણ આપણે જોઈશું અને આગળ પ્રોગ્રામ કરીશું. દરેક બીજી એક સરસ વાત કરી કે દરેક ઉદ્યોગ સાહસિક પોતે ઉદ્યોગ શરૂ કરવા માંગે છે, પોતાનો પગભર થવા માંગે છે, બીજાને રોજગારી આપવા માંગે છે. તો સરકાર તરફથી તો ઘણી બધી સહાય ઉપલબ્ધ છે, તો આપણે એનો ઉપયોગ કરવો જોઈએ. જેવી રીતે આજે વડિયાર સાહેબ પણ અહીંયા મોજૂદ છે અને આ ટેકનિકલ સેશન પછી આપણે વડિયાર સાહેબનું પણ સેશન જોઈશું, જેમાં વડિયાર સાહેબ તરફથી આપણને ઘણી બધી ઉદ્યોગ ધંધાને લગતી વિવિધ યોજનાઓનું પણ માર્ગદર્શન આપણને મળશે. તો વડિયાર સાહેબ હાજર છે, આપણે એમનું સ્વાગત હું નિશા પટેલને કહું છું કે એક બુકેથી અને બુકથી વડિયાર સાહેબનું પણ સ્વાગત કરે પ્લીઝ. અમારા માનનીય ડિરેક્ટર સાહેબનું આજે એક બજેટનું સેશન છે, બજેટની મીટિંગ છે, સર નીકળશે તો આપણે એમને વિદાય આપીએ. થેન્ક યુ સો મચ સર. તો હવે જે રીતે અમારા નિયામક સાહેબે જે આજે પ્લેટફોર્મ સેટ કર્યું છે આ સેમિકન્ડક્ટર માટે, આપણે એને આગળ વધારી અને જે એક્સપર્ટ સેશન જે આપણે સપ્તર્ષિ એકેડમી સાથે આજે આપણે આયોજન કર્યું છે, મેઇન ફોકસ આપણું એ છે કે વિદ્યાર્થી મિત્રો છે, એસ્પિરન્ટ છે, ફર્સ્ટ જનરેશન એન્ટરપ્રિન્યોર છે, જે ઓલરેડી ઉદ્યોગ ધંધો કરે છે, તો એમને પણ એક સેમિકન્ડક્ટર ઇન્ડસ્ટ્રી વિશે કંઈક વિચારવું હોય. અત્યારે તો એકદમ વિપુલ પ્રમાણમાં તકો રહેલી છે, પછી ટ્રેડિંગ હોય, સર્વિસ હોય કે મેન્યુફેક્ચરિંગ હોય. તો આજે આપણે આ ટેકનિકલ સેશન દ્વારા જાણીશું કે મેક્સિમમ આ સેમિકન્ડક્ટર ઇન્ડસ્ટ્રીનો લાભ લઈને આપણે શું શું કરી શકાય. તો આજે આપણા ટેકનિકલ એક્સપર્ટ શ્રી પિનાકી ઠાકર સાહેબ કે જેઓ ઇસરોના સિનિયર સાયન્ટિસ્ટ છે, હાલમાં સપ્તર્ષિ એકેડમીના ડાયરેક્ટર છે. બહુ સરસ મજાનું ટ્રેનિંગ ઇન્સ્ટિટ્યુશન એમને પર્ટિક્યુલર સેમિકન્ડક્ટરની અંદર જ ચલાવી રહ્યા છે. અને અમારી સાથે CED સાથે હમણાં રિસેન્ટલી અમારો ભેટો થયો છે અને અમે આ એક પ્રયાસ ચાલુ કર્યો છે સેમિકન્ડક્ટર માટે. તો હું ઠાકર સાહેબને હું આમંત્રણ આપું છું કે આજનું ટેકનિકલ સેશન તો આપણે થોડું ચેન્જ કરીને ફ્લોરની અંદર હું સુધીર નાયક સાહેબને વિનંતી કરીશ કે જેઓ ઇન્ફોચિપના કો ફાઉન્ડર છે, તો એમનું વ્યક્તિત્વ આપો.
Very good afternoon. So, I apologize for these talks for whatever reason. I am also confused. So, please pardon apology for it. But I can promise you one thing, that you will not regret for time. When you go home, you will be happy. મને ખબર નથી પડતી ક્યાંથી શરૂ કરું, પણ I will try to take you from 10 to silicon to satellite. I think that's the whole agenda. અને સેમિકન્ડક્ટર વિશે પર અત્યારે ખૂબ જ વાતો થાય છે. હમણાં જ અમને સાહેબ વાત કરી કે સેમિકન્ડક્ટર just start plant. I am there on that. Also we user that plant and we are making sure that some big center લોકો કહે છે કે ભાઈ Gujarat has bus IT. I have just modified statement that we missed the bus IT embarked the bullet train. If you remember in one of the Vibrant Gujarat Summit, Tata, those who don't invest in Gujarat are fools, and I am no longer fool. Once again, I have tried to modify the big statement and say those who do not invest, not necessarily money, but those who do not invest in semiconductor, they will regret for their lifetime and next generation. The primary reason is there is no chip manufactured in the world in last 20 years where Indian do not reside. Every chip has Indian, wherever you see the chip. You may not be aware, but in India today we have around 1,20,000 chip design engineers working in 90% of R&D centers. And in USA there are more than 3 lakhs engineers, out of which 50% engineers are Indian. Collectively we are 50%. We are ruling the world of semiconductor in terms of design. We were not there in manufacturing, but I think we are catching it up, and Tata is putting up $10 million worth of manufacturing plant they are going to manufacture, which is called PAC. It is from 28 nanometer to 65 nanometer chip they are going to manufacture. CG Power has 6 micron, inch, and Suchi. They are going for packaging. You will see during my presentation, I will try to, as I said, that I will take you from sand to satellite. So don't worry where the packaging comes, where the chip comes, where the wafer comes. Maybe time is not enough, 1 hour or enough. Can you explain the journey? Because myself, semiconductor device in Gujarat University, we were born in the same year, and 75 years has gone. So that journey is too long to describe in 1 hour or 1.5 hours. But I will try to zip it to the extent possible. And maybe there, if you like what we are doing with Pinakin, we will come again and spend more time with you. Because, but one thing is for sure that I am debating within myself whether I was born too early. Was it a mistake? Because today you may be aware that the kind of the salary which these engineers get, you cannot dream. Their parents has not made that much money in their lifetime. They are making in a year. That is the kind of the salary. The multiplier is nothing less than 7. 10 years engineers, experienced engineers, good engineers. I am not talking about the average people, but good engineers. They can demand 90 lakhs to 1.1 crore. 10 years experience person. Now their parents has never seen that money. And that is the primary reason. And still there is a shortage. 3 years to 8 years band of experience is the most fast moving item today in the market. And the attrition is as high as 20%. We in my own company in InfoChips, we have trained almost 10,000 engineers. Every year we take 500 to 600 engineers. They work for 3 years with us. You cannot provide growth path to everyone. Then they move to the Intel or TI or Google or Microsoft or Apple. There are 52 companies which has mushroomed out of InfoChips. Out of that, 2 companies got acquired. One at 250 crore, another is at 110 crore. Now you think you are sitting on a gold mine. And how many of you know Jason Heng? NVIDIA CEO, he is there for 30 years. He made a statement that when there is a gold rush, it is good to sell the soils and not go for digging the gold. So when there is an AI rush is happening, NVIDIA is making big money by producing AI chips. The market cap of NVIDIA is the highest in the world. It is 3.3 trillion US dollar. They can buy out so many countries. Forget about that actually. Whereas the ChatGPT, their market cap is $150 billion. That OpenAI company, what I am referring to. So there is a lot of money in the chip business. Now manufacturing is a tough. People say that why we are so late in coming up with the chip. But there are several reasons which you will see during my time. But in last 10 years, God has been kind to our country. There is a good rain. And our GDP 20%, 22% is still governed by agriculture. So that is number one. Lot of infrastructure money has gone into in last 2 years, like bullet train, highways, airports, ports, you name the things. There is a stable government and there is a progressive government. So people buying power has increased significantly across the world. It's not only few people, but there is a good distribution of money right now. And there is a big consumer pattern has emerged. Again, you will see in some of my slides that what was our consumption of semiconductor 10 years before and what is today and what is going to be in 10 years time. So all these things put together, once again I emphasize that we all are sitting on gold mine. And that's why I say that I should have born engineer now actually to harvest the fruits of what is happening in the country. After saying this, let me tell you that how many of you have seen the radio? Radio. What is inside the radio? No, that's the point. Because you are in this generation. You are not in my generation. In my generation, we had a vacuum tube valve. And then you used to rotate that knob and that wiper will move. And you can balance there is tuning the capacitors to get that frequency to receive it. So it started with the valve. And as I said, that solid state transistor. The word name transistor came because in 1948, the solid state device, which was named as a transistors, came into picture. And it has replaced those valves. And hence it is called transistor. Earlier we used to call it a radio or transceiver. But transistors came into picture, so that is why when I studied, I have done all my practicals. I passed out from MS University. At that time they were all on the vacuum tube devices, valves. There was only 2 solid state devices. One was operational amplifier 741 and one was NAND gate. That was the only thing we had at that point of time. And the journey started from there on. Once again you will see a lot of slides which I have, that how this solid state one device has transformed the life of every individual. You may not be aware, but most of you are using almost 700 chips every day in one form or other. And if you have a EV car, then definitely you are using anywhere between 2000 to Tesla up to 3000 chips every day. Now just think of, this is one sector, only automotive. When you enter your parking gate, to your TV, to your AC, you name the things. And I think you can, whatever you can see electrical, there is a chip inside. Without chip, I cannot imagine life right now. I also say that if the petrol or the gasoline stops for 3 days, nothing is going to happen. You will survive. But if all chip stops functioning for 3 days, I don't think it is difficult to survive. You will go mad. The life is going to be impossible. That much it has entrance in our daily life. And there is no age bar. There is no poor or rich person. Whenever I try to call my driver, his phone is always busy. Never get it. This is my experience 100 times. Every day when I call him, then he will call me. Two things has happened. Electronics is only business where the price drops every day. Today you buy TV of 125 inch. The moment you bring it home, the price has gone down by 20%. After 1 month, price has gone down 30%. And after 1 year, nobody wants to take it back. You have to give money to take it. This is possible only in this business. Now, if this is the kind of the business you are in, just think of what this technology is going to do. Also, I call semiconductor design and usage of semiconductor electronics is an actor. If you test once this disease of knowing the semiconductor, I don't think you can give it up. I can challenge you. You will forget everything. Even your family will get in trouble. It is so much entrenching. And I am not here to just pop you up to look for semiconductor. This is my personal experience. This is the experience of the whole world actually. And that is why the Silicon Valley got born and they are ruling the world today. Because you might have heard the S. Jaishankar recent statement, the third world war, if it happens, it will not be here. It will be a war of chips. So, starting from your transistor to war to satellite, everywhere cheap and cheap and cheap. So, we are at the right time, we are at the right place, and once again I say that at least know, if you don't want to design, if you don't want to go into business of semiconductor, it is okay. But if you remain ignorant about it, I think you will be lacking something in your life. That is my simple advice to people. Now, what is the basic material of making the chip? Is silicon and germanium. Primarily it is silicon. Now, silicon, where it is available? CED. Okay. Now, though it is said that chip, once it comes in your hand, from the sand to when it becomes chip and when it goes into your product, it travels 50,000 kilometers by the time it comes in your hand. It crosses 70 country gates. Today there is no country in the world which can say that we manufacture chip from sand to silicon to product. Not a single country. Though silicon is the most available, the sand is available. Our Earth, Mother Earth, is the largest holding of sand. 1/4, more than 1/4 of Earth. I'm audible?
Yes.
Okay. More than 1/4 of our Earth has the sand, and that is the primary source of silicon. Now, after knowing this, you will surprise. China is the only country which produces 6 million tons of silicon from sand. Next is Russia. They produce only 6 lakhs metric tons of silicon.
So 80% is already gone actually. Balance world is producing 20%. Why? Because to get the silicon from the sand, it has to go to the furnace. There is an electrode. And then the temperature has to be 2000 centigrade. And the consumption of electricity is very high. And the electrode, carbon electrode, they also get consumed very fast. Also there are a lot of other things which is going to the air. The water is another issue. So nobody is producing. But China controls today the supply of silicon. Whether US, whatever they do it will take years for them to become independent to even get the silicon. There is a Germania. Next is. But most of the people are using silicon because of various reasons of leakage current, XYZ, temperature, holding capacity. Let's not go into that. My title I have just coined it, that golden opportunity in semiconductor knocking your door. And it is in true sense. By the end of my slide presentation, you will know that really it is knocking you, it is waking you up. That please wake up and look at this business. Next please. So I will go it as I said from semiconductor how it got evolved. What is contribution in GDP? The world GDP is somewhere around 100 plus trillion, maybe 120 trillion now. It changes every day because of so many reasons. Journey of sand to silicon. What is the ecosystem of semiconductor? And what is in it for all of you? And then question and answer if time permits. Next. So in 1904, the first wire was produced. You know diode and then triode. So triode is a gas-filled diode. When you heat it up, there is an anode and cathode. When gas ionized, it conducts from cathode to anode. And that is how the current flows. And then came the thyristors and transistors. Forget about all this. This is the basic concept. Next. The first transistor was successfully demonstrated in December 23, 1947. It was demonstrated. It was not commercially available by Bell Labs. Beginning in the mid-1960s, harmonic tubes were being replaced by the transistors. Because in 1949, 1950, the solid-state transistors came into mass manufacturing. See, there are two things. So any technology, when you try to develop, make sure that the technology may be great, but if it not carry any commercial value, then it has no meaning. It is something like the one person has terrific knowledge, but he is not able to express it, then that knowledge is very limited use for himself and for the world. You should be able to communicate the knowledge which you have, you should be able to put to use to the scale of human. See, unless until there is anything today you develop, it cannot be for Ahmedabad, it cannot be for Gujarat, it cannot be for India, it has to be a global thing. Then and then we will be able to compete because of the scale. So whenever you develop, go for the business, make sure that it has an impact on the whole globe. And don't think regional. Maybe for pilot, you can do that for India or for Gujarat. But for the large scale, when you want to do it, think of global thing. Next. So as I said, silicon, how many of you are from atom, you know? Atoms? Few people. What is inside? Proton, neutron and electron on the outer surface. Now, silicon has a 4 valence electrons. Boron has, I am not going into chemistry, elements and atoms, and I think this is not the purpose of today's talk actually. So, I will take it from some platform, presuming that you all have basic understanding of atoms and elements. Phosphorus has 5 valence electrons. So, what happens when boron and silicon, when they are merged or doped, there will be a 1 electron extra. So it has a negative, electron has a negative charge. When it is going to the phosphorus, it has 5. So it is 1 less, so it becomes P. So it becomes P and N junction, that is a diode. And when you make P and P, it becomes transistors. And transistor is well defined as a switch. And that takes you to the semiconductor. See, conductor, you know well, like a copper or a water, which can carry the electricity with a less resistance. That is why I do not get much heated up. Not much of an energy loss is there in the copper. In my village, when I got the electricity at the age of when I was in 7 years. But at the time, all the wires were copper wires. Then they were replaced by aluminum. So copper and aluminum is a good conductor. Wood and plastic is an insulator. They never allow electrons to flow. But then this device gave you a control. Semiconductor is one thing where you can allow the electron or current to flow as per your wish. If the device is not going to saturation, then you change the base current, it will change the collector current. And if you want to use as a switch, then it can. We welcome Desai sir, director of ISRO. We are very happy and very pleased. Sir, please come up. Desai sir, આવી ગયા છે એટલે મારે થોડી સ્પીડ વધારવી પડશે કે આપણે એમનો વધારે લાભ લઈ શકીએ. So this is how PNP transistor and solid state device starts. Next. So as I said, 1948, first commercial transistor by Bell. Then MOSFET 1960, first chip with 10 transistors. The first chip was on silicon slab with a head. There were 4 transistors first, then 10 transistors. Same thing is happening to these devices. You may be surprised to see that when these NVIDIA chiplets are used in any storage kind of the data center, there are cooling towers. That thing has to be the kind of the water which is consumed is phenomenal. Same thing in the fab. Millions of gallons are used per day, and they use ultra pure water. So even packaging plants like, as I said, Micron, so they use 5 million gallons water per day ultra pure, and they process 8 million gallon water to get 5 million ultra pure water. The kind of the electricity which this consumes, all these AI chips, is as good as the power consumed by Germany or Sweden. It's in trillion watt hours. So it looks good on surface, but it's all adverse effect. So this is the story of how this moved, and today, when in 2024 or 2025 beginning, we are talking about the aim is to reach 1 trillion transistors in device. Let's see whether it's possible or not. And I don't know, all of you know Moore's law or not. Have you heard Moore's law? Every 18 months, number of the transistor doubles, size half, price falls. It is reaching now. The latest chip which is TSMC has produced is of 3 nanometer. We are talking about 2 nanometer right now, and I think latest will be at the most 1.5 nanometer. Thereafter, some will talk on quantum computing. I think it is going in that direction slowly. Next. Look at the quantum processor. Can you see? Some of you will be able to see this. How many number of transistors per chips? Every 18 months that will move. So 71 to 96, it has gone somewhere around 1 lakh transistors in the quantum processors. Latest are using billion transistors. IC1 and all those things, 1.3 billion, and in that size. Next. So Intel factory produces Intel is in trouble right now, but I think they will come out soon actually. Once upon a time, there were only few people who used to design and they used to manufacture the chips actually. So what Intel produces is almost 20 million transistors for every man, woman and child on earth actually. That kind of capacity is there. Next. 3 billion in i7 code, which Intel is using right now. That. See, what is the use of this speed actually? Why so much of transistors are within that actually? If you might have seen the translator on the Google Translator or the generative AI, when you use on Google, you write a statement or words, next word is already available. So by the time you finish writing your word, next word is available to you. Now, if you look at the words which are available in the globe today, earlier it was 200 billion words were there in English. Now, after AI, it is increasing every day because there are a lot of churning is happening. But those 200 billion transistors words are to be scanned, and then you have to come up to the next, depending upon individual use. GPT, how many of you know the full form of GPT? Chat GPT, you know? GPT full form, you know? Generative pre-trained transformer. So it is like, આપણે એકડો લખીએ ને તો શું કરે છોકરાને એકડા ચિત્રાય આપણા પહેલા છોકરું એ એકડો શીખે પછી એ શીખે તેના આપણે same thing is happening here also. They just keep training those algorithms and they come out with the best answer depending upon your past history, how you use it. It's like driving the car. You have your own way of driving the car. So when you sit in the Tesla, it will observe you for 500 kilometers and then it is autonomous car, then it will drive the way you have been driving. Same thing this GTP is doing it. And it finds out. But the speed is needed to make sure that you don't waste any time in getting 3 letters. When you get, I want to go CED, it will figure out. Because I have used CED for last 2-4 hours. So it is memorized. And then it will optimize and it will give. So sometimes it can give wrong answer. Because ultimately whatever the data is available in the web or in the physical form, whatever they have absorbed, from that only derives. It do not generate its own data right now. Futuristic things are happening that they predict with algorithm and they try to do it if they are not there. But then the solidity is not there. Next. Golden mood, that's what we saw. Okay. Now, as I explained you that from this end, you take out a silicon, then ignore, they make it cylinder kind of things of the silicon, and then it slides into wafer, which is silicon wafers. So it started like this development, 50 nanometer to maximum is today 300 mm has the optimal use. People are trying 450 millimeter also, but the yield is not that great against the 300 to 450. Now, how many transistors in a chip of 300 mm can come? You can calculate if you want to calculate from the theoretical purpose. Because circumference is pi r square. When you call 300 mm, r is 150. So 150 square is the total area available. Divided by, let's say, 10 mm by 10 mm die. So 100 mm square. So it will give you somewhere around 756 chip per wafer of 300 mm. Likewise, you can calculate from others. And the TSMC today produces, they use almost 16 million wafers per annum. So you can figure out how, for 5 nanometer or 7 nanometer. Then again, it depends what kind of die size you are going to use it. And likewise, there are so many other manufacturers and so many chips and then packaging. So from node of silicon, you slice, wafer comes, that is where the fab starts. Fab where the chips are manufactured. So what it does, it takes the wafer. Tata is not going to manufacture wafer, they are going to buy the wafers from XYZ. Then there is a design house, like Info Chips, or like an edit design by SAT. Then those design will be embossed onto those wafers. And that is the whole job of fab. Then they will give it to the people like Micron or Suchi Semicon or Keynes. They will dice, test. There are a lot of other processes in between. And I think there are 220 gases and chemicals and so many things are happening within that. You need a clean room of different class. I'm not going there right now because that will take time of everyone if I'm going to speak everything about semiconductor. So I will stop at that point of time. And then it goes to the packaging, and after final packaging is done, testing. Every chip is tested, just for your information. There is no statistical method. It's so crucial because if the chip is going into aircraft, or it is going into satellite, or it is going into the car, and if there is a problem in the whole lot, you can imagine what's going to happen. So every chip is tested, every chip. And so OSAT, you might have heard OSAT, the T is for testing. Next. I think we talk about 28 nanometer and 180 nanometer. We had a first fab, just for your information, in India, much before even TSMC. Semiconductor Limited, Mohali, I think it was 1976. There were the first fab. And today I think these Czech people made a lot of use of that fab. And they are 180 nanometer, they are trying for 28 nanometer. I don't know what happens, but that may happen. But we were ahead of TSMC. For XYZ reason, we could not take advantage of that and move forward. Otherwise, we would have been better than TSMC today. But better late than never. We started with Tata now. So, interesting thing is to understand what is this nanometer. Can you perceive in your mind when we are talking about 3 nanometer chip or 2 nanometer chip? Our DNA is 2.5 nanometer. Our DNA. 1,000 times that is bacteria, 2.5 micron. And likewise it goes 10 meters. And if you see here, nanoparticle, it has a 4 nanometer diameter. So what happens is that you can shrink device, shrink. Beyond a point you cannot shrink because there is a lot of other issues of signal to noise ratio, interference and all those things. And there are physics limitations in certain areas. So people are right now, yield also is a problem, the process is also very expensive. So 90% of the chips below 10 nanometers are produced by two people, TSMC and Samsung. No other people. And out of that, majority is still TSMC. Intel is not yet successful in producing 10 nanometer chips. It's very complex. So don't ask why Tata is able to manufacture only 10 nanometer, 65 nanometer. Because apart from technology, there is a other reason also. That 50% of almost use in white goods and automotive and other market, those chips are good enough between 28 to 65 nanometers. So there is no need to go for very complex technology where the yield is poor, technology is expensive, and even the cost of manufacturing also is high. That's the primary reason Tata has gone for mature node manufacturing. So they will start with that, and if needed, they will go after 5 years, 7 years to below 10 nanometer. Next. Okay. Next. So this is the GDP of the world actually, and you can see this semiconductor market along with this is around 100 trillion, 120 trillion the world GDP. Today still US is number 1, China is number 2 with 17-18 trillion dollars. India is somewhere around 3.6 trillion. Only but that is for white money. If you take black into consideration, then maybe we are already number 3. Because we are a parallel economy. Okay. So in 1987, you see the world global market for semiconductor consumption was very poor. In 21, it has gone to somewhere around $450 billion. So that's the reason that India was not looking really at manufacturing from the commercial point of view. There are other issues. We are not going there right now. Next. See, this is where India comes into the picture. Just to give you one example out of this bill, that the internet user in our country is double the population of US. And that is why the internet is the cheapest in our country. And that's why my driver is using phone all the while. You will never get it. You go to liftman, he is always busy. My maid, when she works at home, 15 times she gets the call. I have to go into my room and take the call. Because the availability of the data is very, very cheap. And that is purely because the number of users are maximum in our country compared to US. They may be paying $5 for GB, per GB. We are paying only 3 cents or 5 cents. So you can convert problem into an opportunity. This is the classic example. If I don't know whether you have heard the discussion between Jason Heng and Mukesh Ambani when he was here. He said all your 3 data people, those who are Verizon and all the 3 people put together, he said Jio alone is much bigger than you people, all combined in competition. So that is the power of this population. And since this government is more progressive compared to others and they have spent huge money in kind of people, now there's a lot of freebie even. The Kejriwal is giving 2,100 rupees to every woman and Ladli Bahen and all those things. So money is going into people's hand and they are using it for good. So usage is increasing and that is why everybody is coming to India and they are looking very positive here. Next. There are so many things I can explain on this, but now let's. Can I get back to time? My passenger. 10 minutes, 15 minutes. So these are the people. TSMC, Intel, Samsung, Nvidia, Qualcomm, Broadcom, AMD, Infineon, ST, Micron. These are the players who are in the chip business. Some of them are designing only, some of them are manufacturing only. You will surprise, before 1985, TSMC is the Taiwan Semiconductor manufacturing company. They started first fab, where there is no design, that is only pure play manufacturing of chips in 1985. Before that, all the people in the US or in the Japan, like Philips or you take Intel, they used to design and they used to manufacture and they used to make the product and sell. There were no fabless design house in existence because even if you have capability of designing the chip, who will manufacture them? So TSMC took this opportunity and with some private investment and government, they set up a first fab in 1985. And after that, people like Info-Chips, they started designing the chips for XYZ. They come to us, we design chip for them, and we get manufactured in TSMC or UMC or wherever it is, and then go to the market. So that started happening only after 1985. Till then, these people had a monopoly. But it was TSMC, and that's why TSMC is leading today worldwide. Now the issue is that whether Taiwan with China or is independent or it is where it is not known. So there are always, every day you read in the newspaper that lot of ships are around Taiwan, lot of aircrafts are put in the vicinity of Taiwan, and any day China can attack them and capture them. There is a war going on between US and China, not the physical war, but technical war. As I told you earlier that 16 million ton of silicon is produced by China. That's what US is, and Europe and Japan is importing from them. In spite of that, the trade surplus for semiconductor is more on the US side. they have a more positive to take money from China because all the IPs which are used in making the chip, all the tools, things are changing now. It is not 100% black and white today. But till now, that was the situation that they had the monopoly. Like Netherlands companies, you know, their lithography machine, they totally come there. And they are always in the US. So everybody has to wait for this low technology, it is not available. You have to go and stand in the queue. There is also another reason why you cannot go for lower node. But the point is that all IP and license is there with US. And they deliberately offloaded, in their terms, it's a Gadavar to manufacture. Because the manufacturing has not more than 15%, 12% margin. Whereas IP has, once you develop the IP, then it is a milking cow. Then you just cut the license and you make the money. So they thought, but then it worked for 20, 30 years, but now it is working against them. Because China is screwing everyone now. You cannot cut off China, no matter what you do it. Even India, whatever we talk, but we will not be able to say that, okay, tomorrow onwards we will not buy anything from China. I think it is not that way. Because they have the scale. Anything they take it. So their government style is different, their operation is different. Our democracy is there, it has its own tips and buts. But the fact of the life is that all IP has been, so now China is prepared. Under the carpet they have developed most of it. And we are moving forward. But so far the US and Japan and Europe has ruled as far as the IP is concerned, as far as the license. So this is this comes to today around if you put up all these things in 2024, the semiconductor market global was around 450 billion US dollars. So this is 545, I say 550. There is no standard rules and nobody, it's not accounted that how much is coming because nobody declares 100% whatever is data available. So if it is a public company, then the data you can get it and put it what is the sale and all those things you can derive. But still you can see that Intel, Nvidia, Samsung, Qualcomm, and just for your information, Nvidia and Samsung and all these people, Apple and Microsoft, they don't produce any chip. They design chip or they get design and give it to TSMCs or XYZ to manufacture their requirement. Then it is tanked as Intel or Apple. Intel also is in trouble. They have been pioneers. Once upon a time, 40% of market was with Intel. But right now things are a little problematic with Intel. But that is how it is happening. And we had zero. We had no manufacturing. Except through which, as I said, whatever we do directly. That was the only thing which was manufactured in India so far. Next. So if you look at the market cap, as I told you earlier, that OpenAI market cap and Nvidia, who makes the chip for OpenAI and AI, they are number one today in the world. 3.3 trillion is the market cap, not the goods sold. This is the market cap. So there is a big difference between what is your revenue and what is your market cap. Two things are distinct. I am talking this 3.3 billion is the value as market cap. This is that price, you don't go there. Microsoft 3.3, Apple. Once after 1 year before or 1.5 years before, Apple was number one. But things are changing because of AI. And Nvidia is leading on that. Amazon, Meta, TSMC. TSMC is still, after they have a lot of control, they are just close to $1.1 billion. The numbers are dynamic, they change, but it's around 1 trillion. Whereas the Nvidia is 3.3 trillion. So that's the beauty of IP, design. Manufacturing is manufacturing any day. There is a difference. So you have to take a call whether you want to manufacture. I am talking about this business. Or you want to design the business. Or you want to design the product. That's all. Because if you design the product and manufacture it, it will be story. But if you are just a contractor to manufacture the things on somebody else's design, so I come with the design and will manufacture this product from you and you manufacture, then your margin and my margins are going to be distinctly different. Keep that in mind, because there is no value add from your side beyond a point. Next. So where these chips are going actually? We are talking about $550 billion worth of chip. So what is it, where it is used? This is global phenomena I am talking about. And even in India, this is smartphone, server, data centers and storage. Now maximum use is in storage even today. If you look at these things, the server farms, they are, you look at Amazon and all those people, they have not server, they have server village. You can see from satellite. Like our solar panel, Adani's solar plant, if you look at it, you can see it at Karwa. You can see from the aircraft. Because it's a massive, in 5,000 acre land they have taken. Likewise, these data centers are there. New wave has come in data center also. They are looking at distributed data centers right now. But then there is a problem of bandwidth and latency and everything. So the world is moving in one direction to another direction and trying to find out how to make the minimum use of energy and more so green energy. So I was reading in newspaper last month or month before that Google is going to use 125 gigawatt of power of Adani, clean power, in Gurgaon. So now they are going to produce in Kharwa. So they are going to feed it over here. And they are going to use the power from Gurgaon. So this same energy is not going to be used there. But what they say, whatever you are consuming, that we are buying it from green energy. So maximum usage of chips and power is today in storage and data centers. Because everything, as I think Mukesh Bhai also said, that today's oil is data and no longer oil. Our import of oil import and our import of semiconductor, if you don't manufacture, it's going to exceed the oil imports. This year itself is very niche. So much of import of semiconductor is happening. So server, then consumer electronics, wireless and wired communication is another area. Automotive, wired infrastructure, personal computing, and industrial electronics. I have some data that how much is consumed today in all these sectors and what is likely to be the consumption in 2030 for all these things. If I can put a hands on that. Okay. Server and data center. In 2023, I think the semiconductor use is almost 100 billion worth value. In 2030, it is going to be $249 billion. Automotive, as of today, 69 billion. In 2030, it is going to be 149. Thanks to EV, both in automotive and in charger, both the places. Industrial electronics, today it is 73 million. In 2030, it is going to be 114 billion. Consumer electronics, 71. It will be 114. Wire and wireless infrastructure, 53 billion to 82 billion. Smartphones, today $144 billion. And 2030 is going to be 213 billion. You will be surprised to know that the smartphone business is not growing. It has reached plateau. It is coming down actually. Personal computers and desktop and other things, all covers, not only laptop. 115 billion today, 23, not 24. This is 23 data. And going to be 131 in 2030. So if you just put this total, I am not considering the variables and there are so many other factors which takes other things. But all this put to, it is presumed that $1.1 trillion worth of semiconductor will be consumed in 2030. In 5 years, earlier we had 11% interest rate, so our FD used to get double in 5 years. So there is 11% CAGR for semiconductor. So it will double 545 or 550 to 1.1 trillion in 5 years. We are talking in 25. And 2030 it's 1.1 trillion. So there is a massive opportunity. From data point of view, there is a chip law announced by Biden, and they are giving, I think, $80 billion worth of grant and subsidies and some other forms. Europe has a 42 billion euro kept aside for this thing. India has kept 15 billion. Really, second thing is coming. But when these people went for one more round of funding for semiconductor, they said first show what is happening on the ground. Then you can take. You have already blocked $15 billion and doing nothing because it takes time. So again, money will come. Now just think of if so today. $200 billion worth of fabs and packaging units are coming up only in US. And one political reason is, geopolitical reason is that Taiwan itself, TSMC itself is de-risking themselves. And they are putting up 2 big fabs in Arizona and Ohio. Likewise, they are putting up one plant in Singapore and Japan and even in Germany. So if so many fabs comes, and fab there is one issue. Even if you don't run, it has a $1 billion running cost. It is like your car. If you don't operate your car, see, in so many companies there is a car allowance, so people buy and keep it home. But then you have to have insurance, services, this, that, it has a cost. Battery go down, you have to charge it. Likewise, the fab has to have $1 billion to keep it in the safe. Now, if $250 billion worth of dollars is going into those fab will not remain only. So somebody has to design the chips. So there is a great opportunity for designing and feeding to them. This leads, in my mind, another problem. Even today there is a shortage of good engineers on the design side. Now in all other countries, the scale at which India and China produces engineers, no other countries produce. Nobody wants to become an engineer in English and education. There are better professions, they have lawyers or CE or whatever it is. So what will happen, I think people like Pinaki, they will produce good engineers and they will not stay here. There is going to be so much demand outside that they will go away. I am so convinced on that actually. So every company has to have their own training engine within their organization if you want to maintain their business. These people will produce for others. I am convinced on that actually. I am just making the point actually. This cannot happen, but you just think that if 250 billion, 300 billion worth of money is sinking into this bag and packaging, you will need engineers for sure for designing. And where they will get from? See, we have a scale here. At least our demography also is helping. At least for 2050, we are not worried. By the time I am not going to exist, so it's okay, whatever happens. Okay. Maybe 5 minutes, I will just... So, look at this very interesting presentation to make a point. Who runs this world? Today, India can buy out Brazil. Brazil GDP is 208. Their market cap is 3.3. Likewise, Apple can buy out Russia. Microsoft can buy out Mexico. So 5 to 6 technology companies can buy out half of the world. Now that's the power of semiconductor and AI. So what are we doing, friends? If not you, let your children, your younger brother, your whoever is there, force them, explain them, put the seeds in their mind that this is what is going to happen in the world. And if you miss this bus, there is no bullet train now. At least we want bullet train. I don't know what they will get. Next. Also, the who rules this company? All CEO are from India. They are running all this. You know all the people, Microsoft, Meta. Who is the CEO of those companies? Sundar Pichai and Sexual. Next. So this is what I explained to you from sand, ingot, silicon wafer, fabricated wafer, wafer which is testing, then dicing, packaging, chip testing, product assembly, go to the market. On the top side there is a design. Somebody comes with the idea that I want to have this kind of product. It will go to the chip, design, IP, SOC, pre-silicon validation, design layout, PDA tools, they combine and they will enforce into the wafers. Next. This is how the design sand electronic system. Chip design, architecture design, behavioral functional, logic implementation, synthesis, place and routing, design layout and fired into the wafer. Next. So electronic system design manufacturing ecosystem, if you look at it, there is a supply chain, there is a market, IBM house and ODM houses over here. So all these people put together is the complete ecosystem of semiconductor. Next. So what is happening in the world today? When Google Translator in 2016 it first came, it took 78 months to get the 100 million users. ChatGPT in 2022, they did not get this, but in 23, in 2 months, they got 100 million users. So this is the speed at which things are, dynamics are changing. And if we keep here and just keep listening, nothing is going to change in your life. You have to act. That's the message. Next. So what is happening in India? We are going to consume 110 million worth US dollar of semiconductor in 2030. Today we are in the range of 55-60 million dollars. Out of which 9% is only produced here. Because there are other small devices like small transistors and things. And total available in 2026 we will have 17% in-sourced, manufactured in the country. This is the electronics goods. Today our consumption in the country of electronics goods in the range of $105 million. But most of it is imported. But few of them are made in India. Like we started assembling the mobile, and last year I think we shipped mobile worth $20 million. So value will be very less, but there is a foreign exchange coming. In 2030, we will consume $550 billion worth of electronic goods in this country, and our oil bill will be somewhere around $50 billion. So if we don't manufacture locally, we are going to be in trouble as a nation. Next. This is the last slide. I have many more, but I will stop it. So I think you will not be able to see this, but this is the impact of the chip. Today, the worldwide company like TSMC, they manufacture chip. Their value is $250 billion. Value of those chips manufactured by them, pure chips. The company who supply these chips, after somebody goes to NVIDIA or if it goes to Apple, it's $1.3 trillion. It's going to be $125 trillion of impact in 2030 on electronic goods used globally and other industries which are using these products. So today the global GDP is $120 trillion. In 2030, semiconductor alone is going to expect $125 million worth of business in one form or other. So once again, I reiterate that we are sitting on gold mine. It's our own choice. But I think the challenge lies in executing. Thank you for listening.
ખૂબ ખૂબ આભાર નાયક સાહેબ આપણને સેમિકન્ડક્ટર ઇન્ડસ્ટ્રીના ઘણા બધા ઇનપુટ્સ આપ્યા કેવી રીતે ઇન્ડસ્ટ્રી છે સેમિકન્ડક્ટર શું છે આપણને એન્જિનિયરિંગ આપણે એન્જિનિયરિંગ કરતા હતા ને બી ત્યાં આપણને લઈ ગયા છે તો ઘણું બધું ઇન્ફોર્મેશન જાણવા મળ્યું આપણને ઓવરઓલ સેમિકન્ડક્ટર ઇન્ડસ્ટ્રી હાલમાં શું તકો રહેલી છે એની અંદર ડિટેલ ટેકનિકલ સાઈડ આપણને જાણવા મળી ખૂબ ખૂબ ધન્યવાદ નાયક સાહેબ ચોક્કસ આપણે આજે શીખ્યા છીએ એને અમારું મૂકીશું હા છેલ્લે આપણે જોઈ લઈએ આપણે બરાબર સૌપ્રથમ સ્ટેજ પર આપણે આજે હમણાં NM દેસાઈ સાહેબનું આપણે હાર્દિક સ્વાગત કરી તાળીઓથી દેસાઈ સાહેબ ડાયરેક્ટર છે સ્પેસ એપ્લિકેશન સેન્ટરના જે ઇસરોનું લીડ સેન્ટર કહેવાય અમદાવાદ ખાતે અને તમને જણાવતા ખૂબ જ આનંદ થાય છે કે ચંદ્રયાન 2 ચંદ્રયાન 3 માઇક્રોવેવ રડાર ટેકનોલોજી આવી જે આપણી ભારતની જે ગૌરવવંતા જે પ્રોજેક્ટ છે એમાં સરે ખૂબ જ મહત્વનો ભાગ ભજવ્યો છે તો એકવાર ફરીથી આપણે સરને દેસાઈ સાહેબને આપણે એમનું સ્વાગત કરીશું દેસાઈ સાહેબનું હું અમારા મેનેજર સ્કિલ અને કેમ્પસ ઓફિસર સંદીપ પટેલને વિનંતી કરીશ કે બુકે અને બુકથી શ્રી NM દેસાઈ સાહેબનું ડાયરેક્ટર SSC નું સ્વાગત કરશે ખૂબ ખૂબ ધન્યવાદ NM દેસાઈ સાહેબ ખાસ ટાઈમ કાઢીને આપણા આ સેમિનારમાં હાજર રહ્યા સર પોતે પણ સેમિકન્ડક્ટર ચંડીગઢ અને ઘણા બધા જગ્યાએ સેમિકન્ડક્ટર પ્રોજેક્ટ્સમાં ખૂબ જ સારો એવો ભાગ ભજવેલો છે તો આજે પણ ખાસ આપણા આમંત્રણને માન આપીને એમને આવ્યા છે આ સેશનમાં તો હવે આગળનું સેશન ધપાવતા ટેકનિકલ સેશનની અંદર હું નેક્સ્ટ શ્રી પિનાકીન ઠાકર સાહેબને હું ઇન્વાઇટ કરીશ જેઓ ઇસરોના એક્સ સિનિયર સાયન્ટિસ્ટ રહી ચૂક્યા છે પ્લીઝ
Thank you to the audience. આ જગ્યાએ તમે આટલો સમય કાઢીને અહીંયા આવ્યા છો અને you have proven that now Gujarat is going to be a hub for the semiconductor. સૌથી પહેલા તો નવા વર્ષની આપણી શુભકામનાઓ આપણી જે ટ્રેડિશન પ્રમાણે આજે શુક્રવાર છે માતાજીનો વાર છે તો માતાજીની સ્તુતિ સાથે આપણે અહીંયા એક પ્રાર્થના કરીશું કે ભાઈ અહીંયા હાજર છીએ એ બધા જ અને સાથે સાથે ગુજરાત અને દેશ જે સેમિકન્ડક્ટર માટેની જે આપણે હરણફાર ભરવાની છે એમાં માટે શક્તિ આપે તેસમ મતા જનપદેશુ તનાની તિશામ યશાંસી ન ચ સીદતિ ધર્મ વર્ગ ધન્યાસ્તેવ નિવૃત્તાત્મજ ભૃત્ય દારા તિશામ સદા ભયુદયદા ભવતી પ્રસન્ન અહીંયા જે બેઠા છે એ અને બધા જે કામ કરવાના છે બધાને સર્વ અભ્યુદય થાય. Thank you very much. સૌથી પહેલા તો નિલેશભાઈ સાહેબનો ખાસ આભાર વ્યક્ત કરીશ કેમ કે અમે ખ્યાલ છે કે કાલે રાત્રે અમે 12:30 વાગે વાત કરી હતી અને ત્યારે મીટિંગ લઈ ગયા હતા કોઈકની એટલે એમના આટલા બધા બિઝી શિડ્યુલમાં અને બહુ શોર્ટ નોટિસમાં આપણે એમને અહીંયા સમય આપ્યો જે સેટેલાઇટના જે પ્રોગ્રામ્સ છે એ બધામાં બહુ જ એક એમનો સિંહ ફાળો રહ્યો છે અને બધા જાણતા જ હશો કે ભાઈ ઓલરેડી હી ઇઝ અ વેરી ગુડ ઓડિટર ટેકનોલોજીમાં ગ્લોબલ લેવલે એટલે સૌથી પહેલા તો ખૂબ આભાર છે બીજું CEDનો ખાસ અલી સાહેબ નથી એ એમના હેડ મમતા મેડમ કે જેમને આ એક ઇનિશિયેટિવ માટે એક તૈયાર થયા કે સપ્તર્ષિને એક પાર્ટનર તરીકે પંડ્યા સાહેબે ખૂબ મહેનત કરી એના પાછળ, એટલે એમનો બી આભાર. અને સુધીરભાઈ, એ સેમિકન્ડક્ટરની યુનિવર્સિટી છે, 40 વર્ષ કામ કર્યું છે અને એ પણ ખૂબ બિઝી છે. કાલે જ વાત કરતા હતા ત્યારે 5 મોટી કંપનીઓ જે હોય એનું ઇવેલ્યુએશન કરવાનું શું છે, જે ગવર્મેન્ટની બધી છે, ખૂબ ક્લોઝલી કામ કરી રહ્યા છે. નેશનલ લેવલે અને ગુજરાત લેવલે પણ, અને ISAમાં બી એટલું જ મોટિવેટ. તમે એમની એજ ઉપરથી ખબર નહીં પડે, બટ ઇઝ ધ મોસ્ટ સિનિયર પર્સન ઇન ધીસ ઇન્ડસ્ટ્રીઝ. જિલ્લા અધિકારી શ્રી, આપનું બી થેન્ક યુ. અને હું સ્ટાર્ટ કરીશ હવે. ખાસ તો હું નિલેશ સરને આપણે ખાસ સાંભળવાના છે, એટલે હું મારા સાન્તા ક્લોઝની જેમ આમ તો થેલામાં હું દરેક વસ્તુ લઈને આવ્યો હતો. રાઈટ ફ્રોમ ધ વોટ વી નીડ, આપણે હવે કન્વિન્સ થઈ ગયા છીએ કે ભાઈ સેમિકન્ડક્ટર ઇઝ નાઉ ગોઈંગ ટુ બી અ opportunity, trending, everything is there. Now where we are just catching that. અને એમાં કેચ કરવા માટે ધારો કે સ્ટુડન્ટ્સ છે અહીંયા ખાસ, એટલે જે ટાઇટલ અમે આપ્યું છે કે મેકિંગ ઇન્ડિયા સેમિકન્ડક્ટર ડેવલપ નેશન, ઇમર્જિંગ ટ્રેન્ડ ઇન સેમિકન્ડક્ટર ઇન્ડસ્ટ્રી. અમે 3 ભાગમાં કલાક ઉપર જે નામ અને એ આપ્યો આવ્યું છે, એમાં સાહેબ શ્રી મેકિંગ ઇન્ડિયા, એવી રીતના આપણે સેમિકન્ડક્ટરને યુઝ કરીને સ્પેસ ટેકનોલોજીને બધામાં એ આપશે. એટલે મારા હાથમાં રહ્યું છે કે ભાઈ સેમિકન્ડક્ટર ડેવલપ નેશન. સો હાઉ વી કેન બી ધ સેમિકન્ડક્ટર ડેવલપ નેશન? તો એના માટે હું 2 વસ્તુ કહીશ. એક તો ગ્લોબલ લેવલે, આમાંથી હાઉ મેની ઓફ યુ આર નોટ એબલ ટુ અન્ડરસ્ટેન્ડ ગુજરાતી? તો મિક્સ મેચ કરીશું. ઓકે, સો વોટ ઇઝ ધ ટાર્ગેટ ઓફ માય ટોક ઇઝ what is world is doing right now in semiconductor, what is ecosystem, and where our ecosystem is there, and what is gap between both of them, and how we can cope up that and we can be a developed nation in semiconductor. સૌથી પહેલા તો જે આપણે ફ્યુઝન એમોંગ ટેકનોલોજી, Hello. I'm audible to last? Yes. Okay. So જેમ સુધીરભાઈએ કીધું કે વાલ ટેકનોલોજી, સૌથી પહેલી તો રેડિયો હતો આપણી પાસે, એ બી ફોરેનનો આવતો હતો. હું જ્યારે 9th સ્ટાન્ડર્ડમાં હતો, મિર્ઝાપુર સેન્ટ ઝેવિયર્સમાં હતો, ત્યારે બાજુમાં 3 દરવાજા સ્ટેટ રેડિયોની દુકાન હતી. I have started working from 9th standard, repairing of the radio, state radio. So વાલ જે હતા 127 જે ટ્રાન્ઝિસ્ટર હતા, એવો એક એક્સેલ 3600 વાલ હતો, એનો પાવર હતો એ ટાઈમમાં કંઈક ફ્યુ વોટ્સ, અને એ રિપેર કર્યા હતા. મને મહિનાના 5 રૂપિયા સેલરી અને એક ચા મળતી હતી. So I was happy with that time. જે એમને કીધું કે ભાઈ વિઝનરી હોય એટલે એમ થાય કે ભાઈ આપણે મોડા જન્મ્યા છે, પણ એવું આઈ થિંક દેટ ઇઝ ટુ વે કે આપણો માથે એવી જવાબદારી આપી છે ભગવાને. ખભા જેના મજબૂત હોય એની ઉપર જવાબદારી નાખે, એટલે કે આપણે જે નેક્સ્ટ જનરેશનને હવે ગાઈડ કરવાનું છે. વી હેવ ટેકન ધેટ. ઓકે, સો right from VAL to VLSI we have a journey. એટલે TTL, ECL, CMOS ટેકનોલોજી, એ પછી FPGA, ASIC, SOC, સિસ્ટમ ઓન ચીપ. અમે 17 અત્યારે એક વિચારી રહ્યા છે, 6 થી 8 મહિનામાં એ બહાર આવશે. That will change the Gujarat and nation. What we are thinking on one system, જેમ કે સિસ્ટમ ઓન ચીપ છે, એ એવી અમે એક સિટી ઓન ચીપ વી આર કમિંગ વિથ that kind of a vision and dream. કલામ સાહેબે ઇસરોને એક એ વિઝન જે આપ્યું છે છોકરાઓને એવું બેઝિકલી ટ્રિગર કરવા માટે આવ્યો છું હું આજે કે આપણે બહુ ખરેખર મને દુઃખ થાય છે જ્યારે 97માં હું ઇસરોના સાયન્ટિસ્ટ તરીકે બેંગ્લોરમાં એક VLSA ના કોર્સ કરવા માટે ગયો હતો ત્યારે પ્રોફેશનલનો કોર્સ હતો એ વખતે અમે પ્રોફેશનલ 12 જણા હતા પણ મારી સાથે સાઉથ ઇન્ડિયાના 20 થી વધારે સ્ટુડન્ટ હતા So our students where we are lacking, I think we should cope up now, and that's what I want to force, and I will show you that where we can contribute. બધાને ખબર છે સેમિકન્ડક્ટર પણ કેવી રીતના ચાલુ કરવા આજે હું જસ્ટ એક પ્રયત્ન કરીશ કે હાઉ વી કેન એન્ટર ઇન ધ સેમિકન્ડક્ટર માર્કેટ ફોર સ્ટુડન્ટ્સ ફોર એની ઇન્ડસ્ટ્રીયલિસ્ટ હુ ઇઝ નોટ ઇન સેમિકન્ડક્ટર સો હાઉ વી કેન એન્ટર ઇન ધીસ ફિલ્ડ. Then student who wants to go abroad, how this will be helpful. The entrepreneur, how he can start in semiconductor. Student who wants to do the PhD. So what is that innovation content is there. So today I will be focusing because so many things were maybe repeating. So I will just not do that one. But I will focus on this, how we can do it. આપણા માનનીય વડાપ્રધાન શ્રી નરેન્દ્રભાઈનું એક વિઝન છે અને ડ્રીમ છે કે ભાઈ આપણું 2030 સુધીમાં $3 ટ્રિલિયન ઇકોનોમી બનાવી છે તો હાઉ સેમિકન્ડક્ટર વિથ સ્પેસ એ સાહેબ સ્પેસની વાત કરશે અને હાઉ વી કેન એચીવ ધેટ $3 ટ્રિલિયન ઇકોનોમી. ઓકે, થેન્ક યુ. So now I will start how the fusion of the technology. These are the, I think all students and everybody will know. This is the different technology. Fusion of technology, data mining, data science, embedded, UI, VX design, robotics, IoT, wireless communication, semiconductor, VLSI, mobile, all, civil, chemical. All this technology, this fusion, આજકાલ જમાનો ફ્યુઝનનો છે ને એ ગરબા હોય કે ગીત હોય the technology. It's a fusion. So next please. So this is I have done in 2014 જ્યારે કાશ્મીરમાં પૂર આવ્યું હતું અને બીજી ખાસ એ વાત હું કહી દઉં કે ભાઈ એક અફસોસ છે મને કે ભાઈ આઈટી આપણે 40 વર્ષથી જેમ કે સુધીર સાહેબે બતાવ્યું કે મોસ્ટ ઓફ ઇન્ડિયન CEO આઈટીની મેન્યુફેક્ચરિંગ કંપનીમાં છે પણ આપણે 40-42 વર્ષથી સ્ટીલ વી આર સર્વિસ ઇન્ડસ્ટ્રી ઇન આઈટી એન્ડ વાય સો વી ડોન્ટ વોન્ટ ટુ કમિટ સેમ મિસ્ટેક અગેન. સો વી શુડ આપણે આઈટીમાં એક નાની વોટ્સઅપ કે એક OS નથી બનાવી શક્યા. ધેટ્સ ધ પ્રોબ્લેમ એન્ડ ધેટ્સ વાય વી આર ઇન સર્વિસ ઇન્ડસ્ટ્રી. મહેનત બહુ કરી છે પણ પૈસા નથી મળે આપણને. સો વી શુડ નોટ કમિટ સેમ મિસ્ટેક હિયર. We need to develop application first in VLSI, semiconductor, then only one will give us money. Okay, so I will start with applications and how application, then product, then technology, and where everyone can contribute that I will show you very quickly. So here you can say we have used embedded technology that time in 2014, wireless communication, cloud technology, Ethernet. This is Kashmir. There was in 2014, 2 થી 3 માર્ક કાશ્મીરના હોટલોમાં એમાં પાણી હતું. There was total communication હતું નહીં terrestrial. We went there. We established within 2 days the satellite communication there using all this technology, everything. So this is how we can use the technology for the application, and this is same technology we are using for the disaster management. અમે કચ્છમાં બી કર્યું હતું, ઉત્તરાખંડમાં બી સેમ ટેકનોલોજી વાપરી હતી. જ્યારે આખું વર્લ્ડ થી આપણે એ પર્ટિક્યુલર આઇસોલેટ થઈ જતું હોય ત્યારે we can use this technology, and this is the application. Next. See, this is the application which our team has developed two-way MSS terminal for vessel tracking. જ્યારે બોમ્બે અટેક થયો એ પછી નેવી કેમ ટુ ઇસરો એન્ડ દે આસ્ક કે ભાઈ વી વોન્ટ સમ પ્રિવેન્ટિવ એક્શન્સ કે આવું ફરી ના થાય કેમ કે બોટમાંથી કસાબ આવ્યા હતા અને પછી એની ટીમ લીડ કરી હતી અને વી હેવ કમ અપ વિથ એન એપ્લિકેશન ધીસ ઇઝ દેટ એપ્લિકેશન એ હુમલો એટલા માટે થયો હતો કે 20 સબ-મીટર બોટ 20 મીટરથી નાની બોટ ક્યારેય ટ્રેક નથી થતી આપણા ત્યાં એટલે આપણી ઇન્ડિયન બોટમાં એ લોકો ટ્રાન્સફર થયા અને એ બોટ લઈને બોમ્બે આવ્યા અને એટેક થયો સો what we have given them solution that there is more than 2.5 to 3 lakhs boats sub 20. It was very difficult to track that boats because you need that much bandwidth. So we had given that application and we have developed this terminal using towers as the first 100 proto ASIC જે હતી luckily એમાં જે સપોર્ટ કરવાવાળા ઇન્ડસ્ટ્રી છે બેંગ્લોરની એ બી આપણી વચ્ચે છે અત્યારે અહીંયા અને એ જે આખા એપ્લિકેશનથી નેવીને એક ચાર્ટ જોતો હતો કે હુ આર ધ ફ્રેન્ડ્સ એન્ડ ફો આખી આપણી જે દરિયાની એમાં કોઈ પણ બોટ જાય છે તો વેન ઇટ ઇઝ ટ્રેકિંગ ગુડગાંવ એમનું મોટું કંટ્રોલ સેન્ટર છે એટલે સેકમાં અમે ડેટા સેકથી ત્યાં આગળ તો દે કેન સી જો ટ્રેક થાય છે તો એ ફ્રેન્ડ છે ને જો નથી ટ્રેક થતી તો એ ફો છે તો કોસ્ટગાર્ડ વાળા ત્યાં પહોંચી જાય અને દે વિલ જસ્ટ ટેક એક્શન so this was the system we have developed and I think Tamil Nadu High Court has passed the order કે બધી જ ફિશરમેનને તમે મફતમાં ટર્મિનલ આપો એટલે there was again cost so where semiconductor and VLSI play a role when you want a mass volume there is no other option than semiconductor and VLSI 100 ASIC અને અમે ટાવર્સ ઇઝરાયલથી બનાવી હતી એની કોસ્ટ હતી 52,000 રૂપીસ but when same technology 180 nanometer जो nanometer what Sudhir was talking that is the length of the channel of the transistor એની ઉપરથી ટેકનોલોજી નક્કી થાય કે 180 nanometer કે length of the channel transistor plays very big role એટલે એ 180 nanometer ટેકનોલોજી યુઝ કરીને ટાવર્સ ઇઝરાયલની સેમ નોડ અહીંયા છે SCL માં જે વાત કરી છે એની પાસે અમે સેમ મેપિંગ કર્યું અને that cost us around 800 rupees કેમ કે મફતમાં આપવાનું હતું ગવર્મેન્ટે કીધું કે 10,000થી નીચે કે 20,000થી નીચે આવવું જોઈએ ટર્મિનલ so this is where semiconductor and VLSI plays role કોઈ પણ માસ પ્રોડક્શન હોય અને એમાં જો આ વાપરવામાં આવે તો that will help આપણું ઇવેલ્યુએશન જે તમે જુઓ કે ભાઈ ટેકનોલોજીનું ઇવેલ્યુએશન ક્યારે થયું આફ્ટર 90 બ્રોડબેન્ડ આપણે આવ્યું પહેલા હજુ બી આવી જાય છે ને ઘણી વખત આવે છે આપણે મોબાઈલમાં એટલે ડેટામાં ગોળ ગોળ ફર્યા કરે છે ડાઉનલોડ થતું નથી બરાબર બટ વેન વી ગોટ LTE એન્ડ 5G એટલે બ્રોડબેન્ડ જ્યારે આવ્યું અને બીજી મોબિલિટી તો મોબાઈલમાં ઇન્ટરનેટ આવ્યું that has changed the world and that is where semiconductor has helped so હવે એમાં જે સ્ટુડન્ટ what are the stages where we can do so એ જે એપ્લિકેશનની આ પ્રોડક્ટ છે this is what the architecture જે રીતના બિલ્ડિંગમાં આર્કિટેક્ચર પહેલાથી જ નક્કી કરે કે કઈ જગ્યાએ દરેક વસ્તુ છે એવી રીતના કોઈ પણ એસિક કે સેમિકન્ડક્ટરની આ રીતના એક આર્કિટેક્ચર બને કે કયા કયા બ્લોક હશે ઇન્ટરફેસીસ શું હશે એમાં ઇન્ટરકનેક્ટ શું છે so this is where any right from electrical EC IC any engineer can do this job after taking proper training of 6 months so these are the various and this is that ASIC in first pass we have developed this ASIC next so this is where we had tested with Navy and all
at Porbandar, Coast Guard. Next, please. Next. These are the this is application where in COVID we have developed one terminal which killed the virus. What he told about nanometer, na? I thought that idea that COVID virus was also in nanometer. So same RF technology we have used and we got the patent for this. After 15-20 seconds radiation on the COVID virus, 99% load was killed. So this is what engineer can do. Next. This is what SOTM. This is at the China border. There was an intrusion and they wanted that there is no proof to the UN. So how we can give? So that time we have developed SATCOM on the move. So from this is multimedia terminal. There also we have used ASIC. Next please. So they we have shown lot of application area here. So this is one of car. At what places? Analog IC, discrete, logic IC, memory IC, micro component, optical semiconductor, sensors, actuator, all kind of ASICs are used in automobiles. Next. So now I will just show you that how you can enter. So basically VLSI blend of opportunity. For the student, he can start with architecture course where he can have architecture of the overall ASIC. So what we did is right from architecture to application. Saptarshi is giving courses for right from architecture to application. So you can have architecture. This is front-end design. Then there is a back-end design. The difference between front-end design and back-end is front-end is almost like IT guy. If you know object-oriented programming fundamentals, you can do up to front-end. Okay, so it's like more or less C++ kind of a thing, verification. And so it is not a difficult task, basically. VLSI is not difficult. Students are scared about VLSI, but it's very simple thing if it is taught properly. Then IP development. This is a big market, IP development. Intellectual property development, where we don't, this is again, it's simple for us. We develop IP for so many companies, but we don't have our own IP. So this is the market where it is all the interfaces, I2C, USB, Ethernet, all kind of IP we are buying from the either by the foundry or by the company. So this we can develop, and we have already developed one software-defined radio IP, and we are going to test on foundry, SCA. Then design for test. So when the testing what he told, so here in VLSI, testing is after silicon. But before that we need to plan at the front end, okay, what kind of testing we want. So we insert the automatic pattern generator here. After silicon, it will test automatically what kind of a characteristic is there. So at front end, we have to take care of that DFT, design for test. Verification. It's a good market here for students or for any industrialist. He can have some good verification engineer. I think E-Info Chief says the first job was for verification. And nowadays in industry requirement is 60% kind of a verification engineer and 40% design engineers are required. Then testing also, then VLSI integration is a very important thing. When we do the back end and front end, then integration of that, and we are very untouched with the radio frequency, RFICs. Totally, most of the students want digital electronics. So right now the very big opportunity is there in analog design and RF side and integration. And very few experts are available in India, and luckily we have that full team of that good faculty on this field. Next. So this is what in architecture you have to define the functionality, performance and power efficiency. Involves high level design. So you don't have to go into the technology much in architecture design. It is kind of so electrical person can also do this one. Any disciplined person can go with this architecture design. At least he should know fundamental of digital electronics. And that we have. Next. Then front-end design. So there is a hardware description language like C, C++, VHDL and Verilog. So you have to learn that language. And it won't take more than, if you have a object-oriented programming or C++ background, it won't take more than 1.5 months to learn that. So anybody can start this one. Next. So verification and simulation, that's what. See now why verification is so important is, it is a rule of left to right. When you start your design of ASIC or semiconductor, left side if you detect the problem, it's very, I think, you cannot spend much it's not expensive. If you find some bug after the silicon, so your whole cycle, and in testing if you are finding some bug, then whole cycle is wasted. So time wise and money wise it's very expensive. That's why there is a verification. So at left side you just try to find out that whether any bug in design is there or not. That's why it's very popular, and most of the semiconductor designer want 60% type of a verification engineer so that they can find out the bug in a very initial stage. Then simulation, a lot of simulation has to be done at every stage. Next. Design for test. Here also, I told you, built-in self-test. You have to add the pattern and that has to be tested after the testing so that the transistors are working properly or not, that you can test. Next. Backend physical. Very huge demand for this. Physical design. And this all, I think I have segregated in way. Even diploma student can do this one. And I am trying for even dropout students. So dropout student, I think you will be surprised to know that in 2012 or 13, when Mr. CED came from Coimbatore to meet me and he wanted some access to the SCL. So he was talking to me and he was running these courses for 2 years for dropout students, 11-12 dropout students, and first Reliance chip 2G, which has been developed by Qualcomm, 40% this student have contributed. So this is what is the power of that academy. Any student, it's about he should have some logic. So this is physical design, means you have to physically place the transistors, place and route and all these things. So here what I talk was can be from diploma student, graduate student, masters, and for PhD there is a innovation, things are there. They can enter in any kind of this VLSI flow. Next. Place and routing. So there is, it's like PCB. If you have seen printed circuit board design, it is more or less similar. So finally at this point we make a GDS2 file. Like in PCB we do Gerber file. And this GDS2 file design out. How the whole industry, design industry has come up in India is Up to this GDS, you need the tools. So design houses are there. What Sudhir bhai told. See, more than 1 lakh students or engineers are working to. Up to this point, you don't need a fab. You need a pedicure fab. That is development kit. Which transition. This GDS2, here we call sign off, and this file goes to the foundry. Next. So foundry uses GDS2 and PDK, and then fabrication process starts. Next, please. Then this is now OSAT people have told. There are the different type of packaging. See, earlier, I think, Sudhir, you must be knowing, it's again painful. The visionary of Gujarat, when I was, I think 79, when I was in Surat, SVR professor, Dr. K.U. Joshi sir and Chaudhary sir, they have started semiconductor in Nadia, and they have done first transistor BC147, that was an SN100. But somehow that time government or there was not a vision, but first semiconductor factory was started in Nadia, Hindustan Semiconductor. That's in 79, 80s. If we would have done that right now, Gujarat and India would have been a different scale. So single miss, how it impacts individual and as a nation whole. So these are the different packaging, and nowadays a lot of people want to invest in packaging, OSAT what they told. So this is what we also run the process for this. Next. And then testing. It's very important, and it's a very good setup now. People are there who do the testing job only, Tesco and so many other companies. Next. So here investment for OSAT is from 300 crore to 1000 crore, in between anywhere. Anywhere you can put your, and you can, I think, tie up with the fab and you can get the business. Assembly. So this is where even diploma or dropout student can work. When once ASIC is done, very એકદમ શુદ્ધ ગુજરાતીમાં હું કહું ને તો VLSI કે સેમિકન્ડક્ટર એ અઘરું છે જ નહીં. ઢોકળી કેટલા લોકો ખાય છે એમાંથી કે શક્કરપારા એની બનાવવાની રીત ખબર છે ને, રોટલો હોય એને અમે વેફર કહીએ. સૌથી પહેલા દૂધીના બનાવો હોય તો દૂધીનામાં આમ કાપીએ ને આપણે, એમને પહેલું બતાવ્યું એમાંથી 6 કે 8 ઇંચની વેફર બને બરાબર. અને એવી રીતના જે આપણે આડા કરીએ એને ડાઇસિંગ કહેવાય. શક્કરપારાને આમ કરીએ ને એક એટલે જેટલો રોટલો મોટો જેની તાકાત એટલા શક્કરપારા વધારે, પ્રોડક્શન કેપેબિલિટી વધારે. સેમ વે 8 ઇંચ અત્યારે 16 ઇંચની વેફર વપરાય છે, એટલે કેટલું પ્રોડક્શન છે બરાબર છે. અને એ એસિક બન્યા પછી આવી રીતે ફેબ્રિકેશન કે એસેમ્બલી કરવી પડે. This is what I was talking about RFIC. That is radio frequency. If you see all wireless, automobile, ADAS systems in automobile, everything depends on this one. This is the chip for that. Next. Integration of the product. This is where we have to, I think, product if we develop, then only we can be the semiconductor developed country, nation. And this is what we should, I think, aim for this. And we have a product. Next. So these are the agriculture. In railways, SCL was, I think when I joined 83 ISRO, that time he was doing the product, semiconductor product for railways. Marine, AI and ML. AI and ML is popular because if you give us good hardware performance, semiconductor VLSI is compared with the PPA, performance, power and area. You have to trade off between these three things. So performance where you need a lot of computation, and that's why AI ML has been grown so much, even IT industries. Next please. Then supply chain management. I think where we are lacking is the product and the supply chain. Still we are importing more than 99% of material and equipment of the semiconductor industries from outside. And there I think we should put our efforts there. This is, I think, we are expert in supply chain for other industries. I think it's not difficult for us, we should understand. But there are the very specific, in foundry, there are more than 400 processes. So they need lot of chemical and many other things. So that supply chain is a very good business if somebody wants. Next. So now I think CED, entrepreneur, that is the main thing. They want to develop the entrepreneur. So what is definition is innovator, source of new idea, goods, services and business or procedure, and invest wisely to build the profit. We are very wise. Gujaratis are very wise in this one. So this is what I have shown. Any of the things we can pick up and become an entrepreneur. Next. This is ecosystem. So where now I think there is one request. Government of India and government of Gujarat has supported, and they have a PLI kind of a scheme where they are giving more than 81,000 crores rupees to the manufacturer. But same time, we need to invest something. We are lacking in manpower. We are going to have a huge requirement for the skilled manpower for the VLSI. See, whatever all the flow I have shown, it is not difficult, but it needs skill. And skill comes only if you do hands-on experience. So there is a Saptarshi, the basis of this establishment of Saptarshi is with two objectives. One is to be a intermediate between industry and academia. We have a very good academia set up here in Gujarat, but they need to have an industrial exposure and hands-on training. So we have industrial tools. There are the major four players: Cadence, Synopsys, Mentor, and now it has been becoming Siemens. So they have only these 3 or 4 players are there in tools. So we have licenses for that, and we give them opportunity to do hands-on experience. And we have a very good 30 to 40 years experience team. And then we can also train the professional, industry professional. Suppose one industrial professional is working in verification and he wants to switch over to design. We can train them. If they want some RFIC training, we can do that. So we can take, and this is how, what you need is money, material, supply chain. This is ecosystem. And here we are very weak. We need to strengthen if we want to develop semiconductor nation. This is the requirement. Presently we have to depend on Taiwan and other resources. They are training our people. It should be other way. So I think we should focus more on the request industries, DST to look into an initial stage. Some schemes should be there for the academy or some institution. They are training or skill develop programs. Next, please. So I told earlier, it's a electronics, chemical, mechanical, civil, electrical, software, any field can enter in this one. Next, please. It will give job and entrepreneur to semiconductor will give job to all this field. Next, please. This is what Saptarshi is doing. It can be in IT development, academy, where I shown the courses, architecture, application to ASIC, then establishing prototype foundry also be held, services, design verification. Next, please. So why this Saptarshi? There are the 7 steps of VLSI. So people, a lot of people have told and debate, you name some technical names. But the Saptarshi name given was with proper logic. There are the 7 steps of VLSI and our 7 Rusi, like Bhagwat Rusi. In Bhagwat Center, they have mentioned the design of plane, missiles, even what kind of propellant should be used. Everything has been told in Bhagwat Center. And they have worked. Rishi means who research is Rishi and who implement is a Muni. So this is our traditional. We have to use this one. And that's why this Saptarshi name is given. Next, please. Next. So I will just what is the same picture I am showing. It is artificial intelligence, machine learning, neural network, deep learning, or anything is boiled down to VLSI and semiconductor. Next. Next. These are the various courses you can get information from the desk. Next. So these are the all kind of VLSI courses are available here. Next. Now Gujarat Semiconductor Policy 2022-27. We have a full policy, I think. Dharmendra, you can. It is already available. They are giving up to 76,000 crore for 4 schemes already they are given. This is, I think, linked with the central policy. If they approve, then this is linked with this one, PLI scheme. Next. So this is source for that. You can go through and what are the for various industries, what kind of incentives, fiscal, non-fiscal, all is given here. Next. And thank you. I have so many others, but we will listen here, sir. And lastly, for every lecture, I just request, we are spending a lot of time for ourselves, our family. But at least we, the technical people, should spend few hours in the week for the country. At least country will grow, we will grow automatically. So thank you very much.
Thank you, Thakur sir. Thank you so much for your kind speech. હવે આગળ ટેકનિકલ સેશન વધારતા આજના મુખ્ય અતિથિ શ્રી NM દેસાઈ સાહેબને હું વિનંતી કરીશ કે એમનું સેશન આપે અને આપણને સેમિકન્ડક્ટર વિશે જણાવો પ્લીઝ.
Let me thank the organizers for calling me here. The important workshop. CED, the government, and all those places here. The wasting in time, let me start. But trying to concentrate on how we are using semiconductor technology from this aspect related to space. What are the changes happening in space so that all of you know that in space we use very high reliability components. So any of these newer technologies they may not be available. How we can cope up with that requirement at the same time using newer and newer technologies for space. How the new space era is changing. For this aspect I try to include in my presentation to give some clue to the new entrepreneurs who want to take part in this space era. So all of you know ISRO's origin, so I wanted to elaborate. Sarabhai gave this vision of India's space program. So we are lucky that we are in that place where space program originated in Hyderabad. We used to say that we want to use space research and technology for the benefit of common man and society. કે આપણા જેવા માણસો માટે for common man and society, સમાજ માટે. So he died very young. He also said something which I have written. He used to say that line in the statement was that we are not here to compete with advanced countries to go to moon or Mars or put man in space. Today, when you see Chandrayaan, Mangalyaan, Gaganyaan, you feel that ISRO is doing only those things. Chandrayaan, Mangalyaan, Gaganyaan. You have forgotten the main role of using technology for society, common man. It's not like that. The scenario to acquire some technology. They are all part of the acquiring newer technology. So nobody gave this technology of going to moon or Mars or putting man in space. We have to do it on our own only. Of course, it doesn't have any tangible or meaningful outcome or results for common man, but we want India to be a superpower. Not so far, at least a regional power. So it helps us to develop the cloud in the international arena. For that also all these technologies are required. So Sarabhai died, so then Satish Dhawan took over. Incidentally today is 10th anniversary of Satish Dhawan, 3rd January. Kalam sir, all of you know, so he was a rocket man, missile man and everything. He was in ISRO for 25 years, then moved to DRDO, then Atomic Energy, became advisor to Defense Minister, then advisor to Prime Minister. So that shows his versatility and his great leadership quality, great motivator. Incidentally, his tenure at ISRO was full of failures. That is not because he was not a good technologist, he was a very excellent technologist. But still, there were a lot of failures with rockets. So those were initial days, we have to learn everything on our own, so that was expected. And failure is part of our business. Space is a risky business. That's why technology infusion becomes very critical. If you want to go to space. Satish Dhawan handled ISRO for 13 years after Sarabhai died in 71. 84 years. Here in Ahmedabad, there was space certification. We were all scattered in different places. Some were sitting in like these industrial sets, some were in some college, some were in some shopping center. So all were brought under one umbrella and this gentleman, Professor Yashpal, he was a scientist and physicist, Tata Institute of Fundamental Research, Mumbai. So he was brought here, called here, to take over his role, that is his certificacy center, Antriksh Udyog Kendra, in a satellite. He was our first director of Space Certification Center. I am 13, very lucky number. Here that Sarabhai Kalam. Those days, Ahmedabad and Mumbai, Trivandrum, they were the happening places. So Sarabhai used to sit in PRS, Ahmedabad. Rocket related activity used to happen in Mumbai, Trivandrum. And all of you know, Sarabhai belonged to Ahmedabad, his wife was from Trivandrum. So people used to say that he opened one center here, and one because his wife was not like that. Even Mumbai is the ideal place to launch rockets, being a magnetic equator. So that's why it was set up. Of course, now we have Sriharipur, which is the main. Mumbai is not suitable for launching heavy rockets. This is how we began. All of you know. We do launch vehicles, satellites, planetary missions, and then now human space flights for the application. For which all these things have been set up because of application. उपयोग માટે જ આપણે સ્પેસનો ઉપયોગ થઈ શકે. So, and you'll be surprised to know that all of you have heard about in space, and now space has been opened up to do in private sector, startups from students and all that. So mostly all people are concentrating on these first 3-4 parts. While real business or real money last is application. Nobody is worrying about that last part. Is where technology and application. That is going to be 70-80% of work downstream. People are very keen to make launch vehicles. If ISRO cannot make a good vehicle in 55 years, nobody else can make it in India. That people are forgetting. Student startup, they have that itch to make rockets. But these rockets are not going to help in any way. Better concentrate on this part, applications. How to use different technologies, what Pinakin by showed, how to use that to make various applications. Data is available using to do navigation is there, satellite communication is there. So these were the initial days also. Began in church, carrying rocket parts, bicycle, roller cart, anything happened. Actually, 3rd August 23 was Chandrayaan. Today, this is the space economy. We are here now to see how semiconductor is going to feed into this economy in a big way. It will play a major role. This is our ecosystem. Space is 11 to 13,000 crore per year. That is what we spend in India. Government money. We have around 70,000 regular employees, government employees directly. Government servants, central government. And we are 17,000 static since last 10 years. So that means we are only replenishing retiring people. We are not increasing. So the activities have increased 5 times. So this will be a surprise to all of you. Any organization has grown, but people have remained static. Only 70,000 people only are there last 10 years. So how we are managing? We are managing now more and more private participation and outsourcing of that. That way also a lot of things can happen in private sector for entrepreneurs or startups. So that is where the opportunity is. This is going to increase only, this budget and that. Although now new money will come from FDI and many others. This is how government wants to push. Why we want to do that? This is the signature. Although there is a lot of hype about our Chandrayaan and we feel that we are very great going to moon and all that, but we are nobody in space business. Nobody worries about or bothers about India, in space, global space economy. We are only 2%. You see, not even 2%. Latest report says it is 1.7%. So India's share in world space market is only 1.7%. So India is the sixth largest country by land, and this is the status. That means after जाते अपने सबको पा गए. Reality is something else. We are only 1.7%. Although our population is almost 1/5, or even more. 8 अबज 1.4 अबज आपने. So that means that this is a very dismal scenario, but at the same time it gives us the hope, opportunity that we can pick up. There is a lot of scope for increasing our share in the space market. That is where we have to put efforts. So that is a hope also. So that's what Modi sir wants, that we want to, from 1.7, that is the double to 5%, and if not 10%. There is a scope to go up to 10% from 1.7%. So that is where people start taking up niche areas where you are expert in a specific activity, and there is a lot of scope of doing good business. And as I said, downstream business will be a major activity where people should work. Now, how to do that? So government has made some structural changes last 3 years. So after COVID, so till COVID we were all very close sector. ISRO means ISRO नहीं अंदर भी कोई दाखिल नहीं, बाहर से ही आपको देखना पड़ता है. You pass through that road. So now we are opening up. Today you can use our facility. Anybody can come and use the facility, whether it is academic institute or student startup or a private sector. So these are the changes happening. The government has set up these two New Space India Limited, which is a public sector. पहला अंतरिक्ष कॉर्पोरेशन पे is already there, but that has slowly died out by the market issues. There is Indian National Space Promotion and Authorization Center in space. It is headquartered at Ahmedabad. So that interval, Sarabhai died, and after that Indira Gandhi was searching for a right successor. She zeroed down on Satish Dhawan, who has come from USA those days, and he was director of IIC. So when he was told to take over ISRO, he said he is ready to do that, but he doesn't want to come to Ahmedabad because he wants to continue his academic research also and teaching at IIC. So after that solution was found, that ISRO headquarters, which was in PRL here, Ahmedabad, went to Bangalore. So that way we lost ISRO headquarters from Ahmedabad to Bangalore. Something we gained nowadays. In space being set up, which is headquartered at Ahmedabad. Space will facilitate private sector entry into space. We'll also have 2 more new schemes have come. One is Technology Adoption Fund, TAF. With 500 crore government is sanctioned. So space will fund student startups and new private sector companies to 30 crore per company for a period of 3 to 5 years. So that is one change has come. Another is venture funding of 1,000 crore. So that will also be available. Whoever wants to take up space. And of course there are changes in remote sensing policy, communication policy, navigation policy, like that. In general, total data policy of ISRO or of India, as well as the space policy. That all have been approved last year. So a lot of opening up has come up. So data is now available freely, up to 5 meter data. You can use the data for many other applications. Up to 1 meter you can buy. So there will be a lot of opportunities are there for those who want to work in space. 55 years, 1969 onwards. Recently on 30th December we launched TEDx. After 2 days we are going to have that experiment of walking separation. 7th January morning, 9 o'clock. So we have 2 satellites, TEDx A and B. So one is target, one is chaser. Chaser will go and talk with target. the experiment, because that technology will need in future. Just a primitive technology, my opinion. But still, we have never done it, so it will be a good experiment to do with this SpaceX. So with that, we have now 227 missions. So we consider launch and satellite mission separately. If we add up that, we total of all of these other things, and you know, so I don't have to repeat. This is SAC, so as I was telling you, what is inside SAC, nobody knew earlier. Now, anybody can come and visit us. We have a very good exhibition. This was the first communication art station to build in India by Sarabhai, built by Nippon Electric Company, NEC, Japan, 14-meter diameter antenna. So the art station. We are going completing 50 years of this CED program. Many of you will be aware. Satellite extensor television experience, where you use first time. Sarabhai used to say that if you want to make satellite, make technology, space, first you should know how to use a satellite for application. And as in Modi said, he has stopped many things. Just like that launching satellite, what we used to do last 50 years was we used to launch satellite and then we were searching for users. Instead of that, now we are returning back to that user-driven approach. First users would come to us, I want this communication satellite or navigation satellite, then only we will build satellite. So under that, so the CED program was started as a how to use a satellite to do TV broadcast. So we are completing 50 years of that. This year, 2025, celebrating it. Of course, here we already completed 52 years. This is our campus, main campus. We have 2 more campuses open. So, invite you, students, especially who wants to visit us. There is our station at Delhi also. Indira Gandhi used to go and address the whole country. So we make payloads and applications. And this is where a lot of technology will be used, especially semiconductors. Because payloads are becoming smaller and smaller. So satellite also should have become smaller, but we are not achieving that sort of miniaturization in satellite or rockets. So that is where we are lacking. That's why our satellite and payload weight itself is much high. So the payload carrying capability is becoming lesser compared to any other countries like America or Russia or Japan. But payload, I am proud to say that what we do, the work here at SAC, is developing instrumentation for communication, navigation, optical camera system and microwave radar system. So that is where all of this semiconductor technology we use to make it more and more miniature. And now the trend is toward COTS technology. Because so many satellites are coming up and the technology has improved so much that now we don't have to worry about, as I was mentioning, high fidelity or high reliability component. You can use it because all of you know that your TV lasts for almost 10-15 years without any problem. Any of them. Good quality TV to purchase, you don't have to bother about its servicing. Same component I can use to make a satellite for at least work for 3 to 5 years. Of course, there are some radiation, we are unlucky and radiation hits that, we may lose that satellite. Then you make satellite in large numbers so that anything going bad you replace with a new one. So that is how the trend is coming up, and that's where semiconductor is going to play a major role. First miniaturizing that and then increasing the throughput. So that I can use now newer and newer components. All of you may be aware that earlier, in some couple of years back, space industry used to be at least 10 years behind the commercial industry. So what component we use are which are 10 years older than what we use in the commercial sector. But today that bridge is now lowering, and almost I can use the component which has just come in market. Also, I am using it in space. Of course, there is some risk involved because it is not dead hard or space harder. But that is the trend nowadays. Elon Musk has shown the way to many of us. So this is some details about SAC. I will not go into that because our main name is about semiconductors. So this is what we make, and these are all the instrumentation where all the semiconductor technology fits in. So whether it is microwave radar, the optical camera system, related instrumentation, there is communication and navigation payload. And then of course there is application of data which we collect from this remote sensing satellite. Communication satellite is used for doing data transfer, data communication, and many other things. Navigation, all of you know, 95% of activity you do after you wake up in the morning and sleep at night is governed by navigation, directly or indirectly. We are not aware of that, but we are controlled by navigation system. Navigation is synonymous with GPS nowadays. So GPS is there everywhere. That's why we are bringing in our navigation. This is where activity we do and what activity SET does. As I said, it covers almost all parts you can think of. Compared to our other centers who do only one specific activity, we do all type of activity. That's why the composition of our people is 2,000 people of different varieties. They go for all branches to have some activity set. These were our remote sensing satellite, the optical system initially, and now last 20 years we are making very good radar system. We are almost world leaders in radar nowadays. Everybody is eagerly looking forward to NISA, NASA ISRO radar joint project. Our cameras have improved like anything. This is thanks to the semiconductor technology. Initial first operational camera which our CED team made was like this. 150 kg weight and 4-band camera, which is what is equivalent to what you have in your mobile. It used to weigh 150 kg and such big camera. From that, now we have very small camera, 30 grams to 100 gram camera also now going into space in nanosecond. Of course, they have limited camera. So we have improved from kilometer resolution to 0.38, 0.28. 1 feet, 1 kilometer to 1 feet. That is the improvement in the resolution. Which our camera can take a picture from space from a height of 500 to 700 kilometers. That means we can see even a number plate of a car from space. That is how the technology has moved. And again, thanks to semiconductor. So, as all of you know, this is how the, what Sudhir Bhai also mentioned, from a few microns in late 80s, so 3 micron to 3 nanometer. And most of you will be knowing that what is the limit of this is the speed of light. The speed of light limits up to what lower node you can. So that is what is deep submicron technology. Then now photonics have come and many new things. The light will be the photons will be the carriers. So these are the FPGAs. So you can design ASIC using all these nodes. So in India we are now with this new foundry going to come up near Sanand or Dholera. Of course, as was mentioned, SCL when we started, it was 3 micron or so, 5 micron. We moved to 1.8 micron to then 1.2 micron, then 1 micron and then 0.8 micron, and finally we had 180 nanometer. Now further improved to 65 or 90 nanometer. But here we have mostly I think 28 nanometer or 22 nanometer. Still, we are still far off. The world has moved up to 3 to 7 nanometer and we are still at 28 nanometer. So that itself, to set up that itself will take almost 3 years to make it operational. So how fast we make it operational and start using that is going to be the major factor in these new foundries which is announced by government. So these are some of the older technology. When we started our space work, we started using Intel 4004 for our space setup, checkout system. So we were not using any microprocessor in space those days. Everything was built using CMOS family logics as well as 74 series TTL and all those things. When I joined ISRO in 1986. but slowly we moved on. Then nowadays we are on 2 FP-SOC and RF-SOC. So that means that very high integration with FPGA fabric, with the embedded system, microprocessor, ARM core or many other Cortex and other things. Even GPU are there inbuilt into somewhere with very high speed interconnectivity with SerDes. Similarly, now RF-SOC we already started using. As I said, although they are not red hard or space grade devices, still we use it in space now. So RF-SOC will have built-in RF logic also in it. So I don't have to put additional front end which converts RF signal into analog or finally to D and then processing and all that. So everything is contained in single thing. FPGA based solution. But apart from that, we have parallelly ASIC solution we have built. But as all of you know, building or designing an ASIC is at least minimum a 1 year cycle. It will take minimum 1 year, many times around 2 years also. So that we have been working, but it was our project duration itself used to be around 3 years. In that, if I spend 2 years making an ASIC, it doesn't become very viable. So we always when ASIC, going for ASIC is a technology where you have large numbers. So I show you the example in radars where we have large numbers. We have used around 300 processors. There we have gone for ASIC. But where we need only smaller number, 5 to 10 maximum, there we prefer FPGA. So these are the two technologies that definitely going to be the major workhorses. And these foundries are going to help us in developing these FPGAs and ASICs. First of all. And now the designing Smarcell has come, which has it is like a computer on a chip with its own OS and other things. And now with newer libraries like AI/ML libraries, where you can do very high-end processing also, algorithm which we used to run on workstation or high-performance computer. Now they can be made with TSMC 7 nanometer FPGA. So design-wise, I think Xilinx is a fabulous. Now, why space? We had been always very careful. All of you know that because the high vacuum, effect of magnetic field, extreme temperatures, we qualify any circuit from -55 to +125 degrees. Similarly, there is now great danger. Earlier it used to be less, but nowadays it is increased. Space debris, because every other day satellites are getting launched now. And radiation, of course, is a major factor which has resulted into initially using very high grade devices, microgravity or no gravity situation. So, summarize, space is unforgiving due to the temperature. Any temperature, even 2 degree rise or 1 degree rise in temperature in vacuum, it gets magnified. Many of you may be aware. There is a very big impact on the survivability of any semiconductor device. So it is a real technological challenge, and finally space is after all a risky business. And there were periodic some other problems also. There is radiation, you get solar cycle, and you will be aware that 25 to 28 is going to be the high solar activity period. So during this period, a lot of satellites are going to get affected due to radiation, magnetic, geomagnetic storm. So these are all periodic events that happen. Recently when Elon Musk launched that Starlink satellite, 50 satellites, and they were getting launched, that time so that geomagnetic storm happened and he lost 55 satellites in one go. So that is the risk we get involved when we use or when you want to work for space. And then, of course, any circuit which may be working fine when you launch it, over a period you get degraded. Due to the radiation effect, radiation gets accumulated, which will finally rupture the band. So that total ionizing dose is more prominent in geo orbit, 36,000, about 20,000 kilometers. So most the all navigation satellite and communication satellite, which are in MEO and GEO orbit, they get affected. And single element upset is like luck. So anytime any electron or proton or heavy ion or neutron, if it affects or strikes any circuit, it may damage or it may upset. Even if it is not permanent damage, it has a temporary transition. So your 0 will become 1 and 1 will become 0. So that totally changes the function of the circuit. So then again, either you have to you should have facility to reboot your, if you are using a processor, it should be rebooted. You have to reset it. Like that, many things that you do. So services get disrupted. So that is the impact of that. Many times it ruptures, the single event latch up happens. So it totally destroys the circuit. I'm not going to the details. So these are the effects. So again this, so there could be soft errors which are once in a while event which you can correct by rebooting or refreshing or resetting. Or there are hard errors where you have to use a redundant circuit. That's why we put redundancy in all our space circuits. But nowadays that trend is also reducing. So we put instead of 2 systems, we'll put 3. So it is 1.5 redundancy instead of into 2 redundancy. So like that we try to reduce as much hardware as possible. So that again, large scale semiconductor help in doing that. So by reducing our overall circuitry, we can still achieve some level of redundancy. Not perfect 100%. So these all effects we have to live with when we are using. And one more thing I would like to inform is that these all we can take care when we go for custom ASIC, we can take care by 2 methods. Either radiation hardening in design itself. So I do design my semiconductor device in such a way that it takes care of radiation effects by design itself. So in this design itself, I built in any of the things like enclosed layout transistor, contact guard ring, all those things. So the design itself, it is red hard or red tolerant. Another thing is by process. So all this process which we are going to get in Sanand or Dolera, they are not by process. We will not be able to do that. So by design only we will have to take it. So wherever some very critical satellites we are launching, where we want to ensure that it should have minimum 5 years or 10 year life, and we do still want to use red hat devices which are built or which are procured from a red hat company. We can go for our own custom design where we take care in our design itself so that it will give the required radiation hardening. And in future, whatever technology we are getting here as a part of PSMC or Tata is bringing, so that itself, that process we can improve by making it hardening. So that is subsequent step. First, let the foundry start first and develop some commercial devices, and then we can think of using silicon on insulator or other techniques to make it more and more reliable for space applications. Of course, it will be very costly to go through this process, but you can add on to the existing foundry technology to make it more and more reliable. Then you have other silicon compilers which can also take care of up to some level of hardening. So these space grade devices are also available. So Microsemi or earlier Rectal was famous for its red hat devices. So when we started designing ISRO, we started with this Microsemi device because they were all NT-fused devices first. Then we moved on to nowadays we use more flash-based devices. So they are reprogrammable. So that is the trend now. So using reprogrammable Microsemi RT or RT-G4. G4 is very popular because it can accommodate large volume of circuit. Similarly, Xilinx is more. First time I introduced Xilinx in space for our radar program. So there was a lot of opposition because those days ISRO everybody was using this anti-fuse technology. So again, that is again a big technology jump to go for SRAM-based technology. So they are very prone to single event also. So circuit may be working and suddenly some bit may become 1 to 0 or 0 to 1 transition and your whole program will misbehave. So So still we took that chance, and the radar worked very well for almost 4.5 years. It worked very well. Radar, I said worked radar. Of course, this, as far as designs are concerned, we can have full custom or standard surface, gate structured ASIC designs. Which are part of design methodologies which can adopt depending on the boundary technology which is available with this technology which we are going to bring into this. And overall, if you see, as far as our satellite technologies are concerned or our payload technologies, whether it is communication, navigation, radar or camera, lot of electronics is used there. So there is a lot of scope of having semiconductors into that. And that's where we are going to gain a lot by having our own foundry. Because otherwise mostly we were going to, because as I said, custom. Since we didn't have any foundry and we were struggling to have our own designs. So initial infusion of ASICs or FPGAs into space program was very less. But this availability of this foundry now will give a lot of impetus. Parallelly, it will give a lot of impetus to entrepreneurs also. So they will be outsourcing many designs. So that way people can take up now the foundries available locally. That will give a boost to development of space business as far as foundry technology. So these numbers will increase and the development cycle will also come down. As I said right now, this expertise available at ISRO, which is very high level expertise. With that itself, we are taking 1 to 2 years to make an SE. So that period has to come down. So after passing through that 7th step what Pinakin was mentioning. So, and it has to be, as I said, space being only, you cannot repair it. Other thing in ground, I can always have a next iteration. In space, once you've used it and it has gone with a bug, it will remain like that only. So that's why this, but with foundry available locally, I can go for more and more iterations. That is the advantage we'll be getting. And cost-wise also it will be cheaper compared to if I want to get today. Recently, I will show you an example of Navic ASIC which we have made recently. So we worked almost for 1.5 years. We got the first chip made. It's a 100-channel Navic receiver. It can receive any signal from any GPS, known as anybody. So we got it fabricated through TSMC, but through a third party, that is Moschip. So Moschip was the in-between media for us. So the one iteration itself we took almost 1.5 years. So now if I want another iteration, you can imagine the time to be taken. By that time the device or the technology will become obsolete. So that is the danger we have right now when we don't have any foundry in-house. So that will all win is after getting this foundry. That is where lot of, as I said, downstream application will give a boost where even student startups can take up this activity. So designing is not a very big effort. Anybody who has passed engineering, he can take up design. Once he has developed some experience of designing 1 or 2 ASICs, he can take up any type of So these are some of the other things that are required once you do the design, verification and testing. So all these two emulation tools, simulator, plus simulator, we got recently emulator from Metagraphics, LOC. So these all tools are available with ISRO now. And as I said, since it is new space policy, people can, as entrepreneurs or student startups or academic institutions, anybody can come and use this facility. That is the advantage with new space because nobody approached us till now, and we also don't know how to do the pricing and all that. But it can work out once somebody comes with the proposal that I want to use for emulation or simulation of any chip. It could not be for our work. It could be any other proposal or project you have taken up for somebody. You can come and use this for doing emulation or functional testing or verification. Our team will also help. We will also set up a precedent for future activity on this front where you need not invest in setting up all these tools. That is another advantage. And with foundry coming up, this will be a major activity that we can concentrate. And of course, semiconductor is going to help us in a big way because, as I mentioned, right now we are not doing any onboard processing to a big extent. We are doing something, data compression or some preliminary image processing for generating image or some correction of the image. But the major activity happens of data product generation is on ground, where we use various algorithms, AI, ML and many other new techniques nowadays to improve the image quality, have better compression ratios and all those things, encryption, decryption, all these things. So that is going to shift to space. Is what we are doing right now on ground, that will go to space. If we have devices for that, the devices will come with the semiconductor technology coming up here locally. Because many of the American or European satellites, they have far better onboard processing capability compared to what we have. So we try to rely more on first sending something and then doing whatever correction processing on ground after getting the data. So that can be shifted to onboard. And that is going to be one major area where semiconductor foundry is going to help us in a big way. Because I can do custom ASICs, processing chips development using say GPU or many other newer technologies in a big way within our AIML libraries like Vercel. I think they are giving AIML libraries also. So you can use that to improve the processing capability on board. So the data downlink rate also will come down. So that will increase the throughput rate of the set. So this is what roadmap keep on devising that because we have newer and newer devices coming up, both in optical and microwave radar domain. So whether it is radar-based systems or high-end radar systems, these are going to be more processing intensive, where the ASIC technology is going to help. These are just few examples of like where there is a control mechanism is there that right now we have to depend on standard chips available. So that I can make a custom chip and design all interfaces also within the same chip. So that way it will help me miniaturize and implement whatever algorithm I want to make. So this is the comparison. If I go for a standard FPGA, actual FPGA, which is red hard, red tolerant. So this is what I am spending power-wise or volume-wise. If I do it with this, so ASIC will offer me all type of advantages. So cost, power, all advantages are there, including volume. So that is where availability of a foundry at hand locally will help in this. Similarly, if we had our very thriving radar program, we started in 70s. Today we are world leader. We have made not large number of radars. So again, here we have achieved hundreds of meters to 1 feet sort of result. There are three this type of radar. The first radar we bought from Israel at a cost of 800 crores. After that, we have made 3 such radars. In total cost of 1 radar which we bought, that is 800 crores. We have built 3 radars. We are now operational, taking care of our strategic requirements of surveillance around the border areas. So this is how having our own. So with now foundry coming up, this cost will further come down. So many things which we are importing, we can do it as a custom development. And this is one example why I keep claiming that we are world leaders in radar development. After our first radar development, NASA approached ISRO, that is JPL came to us, SEC, and with a proposal that they want to do a joint work radar development, where the offer was that they will make radar and ISRO has to give satellite and launch vehicle. But we didn't agree to it. Nobody dared to say no to NASA or JPL. JPL is world's best aerospace laboratory. NASA is world #1 space agency. But India or ISRO has the audacity to say no, that in 2012 when we made our first radar. So afterwards we had a lot of discussion and final compromise that we will make 2 radars. One will be made by them, JPL, one will be by SEC. So this is our radar. So their radars both are integrated as one single radar. So this is that radar, and it is now getting integrated with our satellite at Bangalore. This antenna is from US only. Astro in USA. So they have given this antenna. It is a 12-meter diameter antenna. So this total thing is right now in stored condition. It will be launched by March or April this year. So it took almost 12 years to build this, both of us, JPL and CED. So the whole world is really looking forward to that because it's not coming forward. So because there is some application called land deformation study that could be precursor to future earthquake prediction. Right now we are not able to predict earthquake. We can predict cyclone. When cyclone originates from that time onwards, we can predict its path, we can track it and all that. There are very few deaths nowadays with cyclone. But earthquake still it is unknown. When it occurs afterwards only we will know it. So this could be one precursor to future. We may be able to predict earthquake also after studying this data. So this is the radar which we have built. A lot of semiconductor technology has been used in that, including RF technology, what Pinakin was showing, the TR modules, and many other things. Of course, this foundry is not going to support RF technology, but we already have GATEC foundry in Hyderabad, which has been having technology from France. So that can build RF modules, which can be utilized, especially power amplifiers and receivers. And these are some of the digital assets which we built when we started our radar program from 2000 onwards. We launched satellite in 2012. So this was the first asset we built using an Italian foundry. And it was 0.6 micron CMOS red hat. This is red hat. We only did the design, front-end design, that too with the help of CG Coder those days, in 2000 to 2010 time frame. And it was fabricated in Italy. The foundry was in Italy but under US control, under the Aeroplex. That was 0.6 micron. And then its local Indian version we made OPC 2.1 from SCL foundry. So again we did the design, we tried to make it red hat. We have to remove lot of memory because memory is prone to radiation effects, single event upset and many other things. So that we had to remove that. But still we could achieve certain level of red hardness with 180 nanometer. So that was a big achievement. So that way we can use this foundry. Even though they are not red hard, you can by design you can take care. So where it is really very critical. This is a critical component. Microcontroller or processor, if it hangs up or it doesn't work, then whole system is lost. So that's why we took that risk and it worked very well. So we are using almost 300 such devices in our RISAT-1A satellite which is in orbit right now. In RISAT-1, the first radar which we use this fabricated in Italian foundry. Today we are making many ASICs, but starting with A2D converters, microprocessors, microcontrollers, and many small devices, interfaces and other things with SCL technology. So 180 nanometer itself we are able to achieve this. So with this 22 or 28 nanometer basically basic core is 8051 or 8031 microcontroller. And we made it red hat, working in these 3 different systems. Type electronic, that is ER control and type control, and we made one more controller of the radar system. So this is an example how semiconductor technology can help. Otherwise, I cannot think. Going with this ASIC, you can see the structure of this radar. It is a 2 by 6 meter big antenna is there, and it contains 300 TR modules. So there is RF miniaturization also with the GATEC technology, what I was mentioning. and digital part is using OBC SE. So with this itself, it is a very big structure. So you can imagine if I don't have this SE called RF module, it is almost impossible to build such a phase radar. So that is the advantage. So now we are making this new SE also. 32-point floating point also included into that. So like that, we are going on improving that. And as I was mentioning, the data product generation, which is right now happening on ground, and various corrections, radiometric, geometric, many other new thing, enhancements and other things. So that we can shift it to onboard. Once we have semiconductor technology or FPGA with advanced features like AI, so that is where it is going to happen. You may be aware that now trend is towards, earlier we used to get raw data from satellites and we process it on ground and generate data products. Now people want information product directly from satellite. So many things have to shift to on board. And now the trend is towards analysis ready data. So data is in such a form that straight away you apply your algorithm, do the analysis and come out with results. And now trend is going to be AI ML ready data. So you can directly apply AI ML algorithms onto such data and you should be able to generate the required application which you want. So that is how product generation is going to be. Similarly for application also, lot of new things will be required, which right now we are doing all in software. So one is we can improve computer, high performance computer itself will become smaller and smaller so that the cooling requirement and all that comes down in HPC. That is one way semiconductor is going to help. HPC is a big user of all semiconductor technology. Apart from that, I can go for hardware accelerators like FPGA based systems, Vercel type. It is called accelerator system. So that will also improve the processing capabilities of the ground computers also. So both ways it is going to help. It will help me to do applications in a much faster and more efficient way. These are two of our websites where we showcase a lot of applications. So nothing to do with semiconductor. Semiconductor is going to indirectly help it by speeding up the processing in the application. Similarly, that was remote sensing. Similarly, communication satellite and navigation satellite. So we had a big history of developing our own indigenous system. After the first INSAT-1 series, it was bought out 4 satellites from Ford Aerospace, USA. We gave a contract to Ford Aerospace. And out of 4, 2 worked, 2 didn't work. One didn't get opened up in space, other one power supply failed. So even when Americans do the job, they also are like us. And if you see, traditionally communication and navigation payloads are more conservative, traditional type, because the life of the satellite is high. For remote sensing satellite, there is only 1 year to 5 years or 7 years. And low Earth orbiting, they are operating from pole to pole, moving satellite. But communication navigation satellite, they are stationary satellite. And we expect their high cost item first thing. So we try to pump as many technology or as much capacity as possible in the satellite. And we want life to be very much higher. So it is minimum 10 years to 15. So that's why we go for more traditional approach rather than being more enterprising. Like in remote sensing, I go on using newer and newer technology. But here we try to use very proven and older and red hot technologies. So there again we have to now change the approach, and that the approach how we are changing it now. Although these are all built on traditional designs where we have different types of transponders. So high power recently we launched last year. We said 24. There are 24 high power DTH channels. So this is now handed over to Tata Sky, which will provide all the DTH services in India. So because first time such a high-power satellite was built. But as I mentioned, it was all based on traditional technology. So there again we can go for newer technologies. And similarly, navigation payload, there is a lot of scope because all of you know GPS satellites are becoming much and much reconfigurable. So from ground I can reconfigure it for any application for navigation. So we are now also going in that direction for as far as this. And one more change which is happening in this type of traditional that is a broadband satellite system, high throughput satellite system for communication, was that now it is going to be SDR based, so software defined radio based. So I can configure it to have like this one all India beam where it will be used for DTH. And same satellite I can configure to provide broadband services all across the country with small beams. So I can convert same hardware from a single beam to multi-beam. So that is going to be the different, although we are still developing that. Right now we have separate single beam satellite and multi-beam satellite. And both use different technology. But now same technology will be used by doing like a program, like you program your microcontroller. So we'll give telecommand and that will change the configuration of a satellite from a single beam configuration to, it will become from DTS satellite, it will become a broadband internet satellite. So that is the change which is going to come. And that again it is possible only because of semiconductor. This is going to be the example. So that was geo satellite, and now trend is after Elon Musk has shown OneWeb is now Sunil Mittal has taken. It was actually UK constellation. Now Sunil Mittal has taken over this. Now India in that way. So they have been already given permission to provide services in India by InSpace. Starlink has also applied for providing services in India, so that is under construction. If you remember during election time, Elon Musk was planned his visit to meet Modi sir and suddenly got cancelled. He went to China. So maybe he will come again to ask for this permission to provide services in India. So right now he is providing services almost many places in the world. But India is not allowed to provide. So already he has 6,000 satellites already launched. And he is planning to put 20,000 satellites. The importance is Russia-Ukraine war is almost 3 years it is going on. Russia has bombarded Ukraine like anything. Everything is gone there. TV towers or communication towers. But still TV is working in Ukraine and internet is also working thanks to Starlink. So that is the importance of such satellites. Starlink, so as I said, 6,000 satellites. So this is going to be another technology where now here the trend is, again semiconductor has played a major role. That earlier each satellite will cost us minimum 100 crore to 300, 500 crore. But with now advent of the Starlink approach, now we want each satellite to be only 5 crore or 10 crore at the most. So we'll fabricate 50 satellites in one go, test only one out of that. If that works, we accept all the batch of 50. If it doesn't work, we throw out all 50. So that is how he works. And he launches 50 to 60 or 80 satellites at one go. So whenever he doesn't have any customer in Falcon, he launches Starlink satellites. So that is why every week he launches 3 satellites. Three launch vehicles per week. In 3 launches per week. This SpaceX is that Elon Musk. ISRO launches 3 missions every year. Now you can imagine where we are. We made 3 launch vehicles, GSLV Mark 3 type, in 1 year. 3 also is not true, it is only 2.5 only we make. So every 2 years we make only 5 launch vehicles. Well, Elon Musk within 1 week he made 3 launches. We recently we got GSAT-20 satellite, high throughput satellite launched to SpaceX because its weight was 4,400. Our launch vehicle can carry only up to 4,000. So due to that extra 400, I have to go to SpaceX. He charged 500 crore for that launch. So some 5-7 people came in Florida, launched it, and within 2 hours everything was over. And the first stage was also recovered from ocean. and it was again started. They started refurbishing them so that it is get ready for next launch. And here, when we launch any satellite, so 200, 500 people will gather, clap and do and water. So that is how professionals work. It is an example of how we should be working instead of doing all that fanfare. So that is the importance, and that is why semiconductor technology has helped in a big way. That now satellites are all commercial off-the-shelf devices, because it is all digital beamforming and inter-satellite links and many other new technologies have come, which would not have been possible with red hard devices or all. It is almost impossible. Cost will also be, as I said, 100 to 300 crore. Well, right now he makes 10 crore or 20 crore satellites. So that he is planning to make 20,000 satellites in order. That has also increased the, as you can see here, it is now like traffic congestion on our roads. It is traffic congestion in space. Even in air also we are saying, when we are in Bombay or Delhi, or your aircraft will go on in space in air for almost 1 hour or so. Now you can imagine, recently when we launched SpaceX, the launch was at night 10 o'clock, but we only had window of 10 seconds. So if you miss that, we have to wait another 5 seconds, because one Starlink satellite was coming in between our orbit. Because that SpaceX we are trying to put at 470 kilometers, and all Starlink satellites are within that orbit. So we have to be very careful of this. It's called space situational awareness, space debris. Any satellite can hit you. So your launching is becoming now very critical. So we have to maintain close coordination with Starlink. So regularly, one team is regularly engaged with working out. It's called POLAR, collision avoidance scenario. So that we have to specialized team working for when you do launching. And another, they say the semiconductor is going to help in this technology, Bluebird. One we are going to launch one satellite, 2 satellites for them, Bluebird. So this is that 64 square meter antenna in space. As I was mentioning, complexity is moving from ground to space. So this is for to make your mobile phone, smartphone, a satellite phone. So today when you go to some remote area or rural area, you don't get connectivity. So you get very frustrated. That will be thing of the past. So already that experiment they've undergone. Using Starlink also they've done. That now automatically when you don't have network connectivity through terrestrial network, you get shifted to satellite network. And that will be automatic. So you don't have to worry about it. With same power. So you cannot carry higher power in your smartphone. Otherwise it will be hazard for human being. It cause cancer. So that is the experiment they did with this satellite, Blue Walker 3. So 64 meter square antenna, they use beamforming and other things. So the same smartphone, you will be able to communicate at the height of, so the low Earth orbit satellite. All Indian boats use this terminal which is made out of this model. And we also have NAVIC receivers. So continuously the position will be transmitted goes to Indian Navy at Group ground. They have a control center and they monitor activity happening in the Indian Sea. There are some different assets which we have made. So these all will get speeded up with this semiconductor technology or foundry at our hand, so that I can do the iteration in much faster way. So these are all This is another project we are taking. Initially, we planned to have lower orbiting satellite, that is tracking of all our aircrafts. Right now, they are Airport Authority of India is hiring services of Viasat, I think, who provide when they have all the aircraft. Our aircraft as well as any other international aircraft, when they are in the ocean region, they are not able to communicate with ATC. So to track them, they get services from satellites. So they go through Viasat. So Airport Authority, they are paying every year, I think, 100 crore rupees to Viasat. So instead of that, they wanted their own satellite. So they told ISRO to make it. So when we come out with around 65, three options are there, 48 to 65 satellites, low Earth orbiting. That is one option. But now we are going for what we call geo-orbit satellite. So we need one or two satellites only. Of course, we have to work out link matching and many other things. So that will help us to track, tracking all the aircrafts when they enter Indian region, so Indian flight zones, VFIA. So all aircrafts are getting tracked. So we get large number of messages which have to be, there is latency period within 500 milliseconds or so. All information should come to Airport Authority. So then only they will be able to continuously track which aircraft enters Indian region. So Navy has a big semiconductor role for the Navy system. So this is equivalent of GPS, or Indian GPS. The GPS are on mid-Earth orbit, orbit satellite, 20,000 kilometers. Our satellites are at geostation, that is 7 satellite configuration. We almost completed 25 years this year. Still we are struggling to make it operational. So that itself shows the complexity. So space segment plus ground segment plus user segment, the receiver. That is where we made mistakes. And there were a lot of many changes which has happened in satellite also, we could not design properly. So finally we are still struggling to make it operational. Again, semiconductor technology is going to play a big role, especially in user segment. So we want as much miniaturized, it has to come in your mobile. So only one chip costs you around. Right now we are using it for various governance applications, so like tracking of all trains. So already around 7,000 trains have this technology. So on navigation, plug and receiver. Similarly, this space fishermen, as I mentioned, 4 lakh ports going into this thing, and aircraft of Indian airport also. The technology is same, so you have a Navic receiver and a SATCOM terminal combination, which is called in NAVCOM applications. So this is going to be big application for this technology. And of course, Navic is going to replace GPS wherever possible. Wherever not possible, it will augment it. Because nowadays trend is towards having as many satellites in view. So you use all these satellites, whether it is GPS or Russian GLONASS or Chinese Beidou or European Galileo, Indian Navy. So a large number of channels. So this is that 100 channel receiver which we built, and if you see the block diagram of this, whatever you study as part of electronics and communication engineering from semester 1 to 8, everything is there in this chip. RF technology, embedded processing, signal processing, antenna, and everything. Whatever all subject which you have learned in semester 1 to 8, everything is there here, some way or the other. And the cost is only 70 rupees, cheap, 10 cents. And you go as one single unit in your mobile. So then only people will use it. It will be that much cheaper and that much miniaturized. So that is where in big way semiconductor technology is going to play a role. And already we have, as I said, through most chip we have designed this. So we have done the front end design and handed over the code to them, and it contains that strategic code also, which is encrypted. So it is a big risk, if they can break it, then all our military installation, everything will render it vulnerable. So we have to take care. There is 4 level of security built into that. So encryption is the last stage. Before that, there are many things, long code. In code itself, nobody will be able to detect. So if they not be able to log through it. Then over above that data structure, means signal structure where each bit means what, that itself nobody knows, except few people in the whole country. So all these things are the security features built in. Then over and above that, the JCB called DRDO, they control the overall encryption. And we have our own inbuilt encryption into that. So that type of 4 level of security. Initial chip when we made it a short code. So that, and then we told our young engineers who just recently joined SAC that you try to decrypt it, break that code. Within 15 minutes they were able to break it. We didn't tell them anything because it is repeated. You can capture data and apply different parameters and combinations. You will be able to lock. But now code is such that it is called long code. So it repeats after, it is called pseudo-ranging code. It repeats only after some time, very long time, some n number of weeks. And before that, if I change the encryption key, then anybody who wants to try to break it, he has to capture data again. So in between, key will keep on changing. So it is impossible to break it. But still there is a risk with now quantum computer coming up. A quantum computer like AES code, if some of you have heard about it, advanced encryption code, the system. That codes are almost unbreakable. But with quantum computer, now they can break it within 1 day or so. So now you have to go for what you call QKD. So using same quantum technology, you now do encryption. So that will be again unbreakable by even quantum computer. So that is the risk. Younger generation when they grow, this quantum technology is going to be there. So these are some of the receivers which we made using ASICs. So ASIC is going to play a major role in navigation systems. So navigation system need, so we are using it for our Lagrangian quantum application. Quantum needs very precise timing synchronization. And right now we are working on what we call all these GPS, GLONASS, NAVIC, all these are Earth-based GNSS system, navigation. See, I am able to receive GPS signal or NAVIC signal even on moon. You'll be surprised to know that from the side lobe of the antenna. And with that I can do navigation. But of course accuracy will be hundreds of meters. It is not 5 to 10 meters which you get on Earth. But now there is we all countries, 6-7 countries and America, they are working and we have joined recently with pseudo-light system. So this is one satellite which is going far off. So it has received signal. It is the highest distance where GPS signal has been received till now. So check on it. They continuously update this signal distance. This flight was around 200,000 kilometers away. When the satellite was that much away, he could receive GPS signal from the side lobe of the antenna. So you need but very high precision, high sensitivity receiver. So this is the scenario where, as I said, each country will launch one satellite. So you have navigation satellite across moon. Around 4 to 5 satellites are good enough to. The GPS is a constellation of 32 satellites on Earth. But on moon you will need around 4 to 5 satellites which will be able to give you good positioning. So it will help me in landing. Why we are doing all this? When we are, right now we did landing. It is totally based on INS system, accelerometer, gyros and all that. So it was risky. But if you have navigation system, you can have precise landing. If you have GNSS system like this. So that is the aim with which everybody is working. Because future we are planning to have space colonies on moon. So that time you will need precise landing and all that. If you want to go to, like you want to go to Bombay, you should land in Bombay only. Right now I may land anywhere. Our accuracy was 500 meters when we landed on moon. With now one Lupex mission, I'm sure we are landing going to moon. Now, these are some of the areas identified under Prime Minister's Science Technology Initiative. So we have started working on this quantum frontier and AI/ML, of course, till automatic communication stop due to this photon technique. So, and then we will key distribution will happen through satellite all across the country. Right now, if you want to do key distribution using fiber optic network, it can go only up to 10 to some 100 kilometers. Then repeaters also will not work. So that's why you need better systems. So satellite will be that system. So this experiment we did between two buildings in space, 300 meters, and we demonstrated up to 400 kilobits with a weak coherent pulse, single photon. And entangled photon means security is increased, but data rate decreased. So data rate is only 1.5 kilobits, where security is increased too much. Here with this single photon, we could achieve 300 to 400 kilobits per second. But you don't need higher data bit. But when you go to space, this rate will further decrease. This is between building in space, in air. But when you go to space, then distance will increase. So either I have to use better devices, which right now are not there. Right now with available device, I am able to achieve only this much. So when I put this same system in space, this 300 will come down to some 10 bits per second. So with current technology, so lot of scope for further improvement with semiconductor. That is, instead of ASIC or RFIC or CMOS IC, it would be PIC, photonic ICs. So that is going to be next step in semiconductor. So these are all the building blocks for this optical opto-quantum system. We'll be doing that experiment. And a lot of new other technologies we are developing, where semiconductor has a role to play, whether it is developing a transmitter or earth station in K-band. Right now, India can develop only up to KU-band. Bell and other people are doing that. K-band still we are importing. So when we launch a satellite to 1,000 crore, I have to buy another 250 crore earth station also. Then only a whole system will work, which is all imported. So a lot of scope for entrepreneurs who want to do new things. And we are building a terahertz scope where we are going towards higher and higher frequencies. Right now, all our other up to KU K-band means up to 20-30 gigahertz. This is sub-millimeter means up to 300 gigahertz, and then teragigahertz means 1000 gigahertz. So that is how trend is going. Similarly, detectors for all our camera systems we are buying from foreign countries, mostly USA and Europe. So France and Germany and USA. So now we have started designing that. Now with foundry available, that will be a big boon for our camera system. So right now, IR detector they don't give. Even if they give the low-end device only. So night vision is not possible. That's why our camera don't work at night. You need IR cameras and further newer technology. So these foundries will help us if we have our own foundry. Of course, this foundry will not be able to fabricate IR device, but still we can always improve upon that in future. So once something starts rolling out, so these are all the quantum approach. So where lot of role will be there in semiconductor. And of course, Gaganyaan is going to be one other area where lot of use of semiconductor technology is going to be there. Lot of things will be outsourced. So that way also entrepreneurs, startups, and many other people will have a major role. We have this almost, if you see technology wise, it is the service model is like satellite, which we have right now. Launch vehicle is, we have that launch vehicle. Now we have to put only this crew cabin over this satellite, so this will work as a composite, which will be put inside this and launch. So we have almost all elements of launching Gaganyaan. But what we don't have is that safety, because this may fail anytime. So I cannot give guarantee that one who is going up will come down. So then who will go? So unless then I cannot fly also. So like aircraft also, flying by aircraft you are sure that you will land in Bangalore or Trivandrum or wherever. But here you are not sure till right now. We are working on the human-centric or safety aspect, and that's why it is getting delayed. So these four gentlemen have been identified, they have volunteered themselves They are test pilots. They are Air Force pilots, and there is one category even above normal pilots. They are called test pilots. So they are of that category. So out of 10, 4 were selected. All have undergone physical training in Russia. Now they are undergoing other technical training here in Bangalore, where we have provided video simulator. Cabin will be something like this. 3 people can sit there. So we don't know how many will send. 1, 2, 3. That is yet to be decided. And another requirement is 100% communication. Right now, it's all possible thing because this Gaganyaan will be always moving from North Pole to South Pole. So only 2 times it will be visible in morning, 2 times in the evening on India. Like I will say, control station will be in Bangalore. So with all that, we are able to achieve only 40% communication. From 40, we have to bring it down to 100. So for that, we will have to launch another 2 satellites on geostationary orbit, so that wherever Gaganyaan is, it will communicate with that geostationary satellite, and that satellite will be constantly looking towards Bangalore. So that way, and then coordination is required with various ground stations of other countries. So that way together we will be able to achieve 100% communication. So that is the challenge involved. So again, lot of technologies are to be brought in, newer things to be done. And finally it will be 1 to 7 day mission. And it will be launched from Sriharikota, come back either at Veeraval or near Andaman Nicobar or Goa. It is still not decided. And in emergency, they have to be built out anywhere in the world. So it could land on land also or ocean also. And we have time window of 90 minutes. If something goes wrong, we have only 90 minutes to take them out. One option was docking them with ISS, space station. Like right now, Sunita Williams has been put to that space station. So that way we can also do emergency, but that docking interface we have not put, or we are not going to put. So that is going to be, for us, it is another challenge. If some emergency comes, they have to be evacuated to the crew escape system. Another thing we tested was on launch pad itself, like Challenger space shuttle, it exploded. And they were not able to take out astronauts. So I cannot open the door and take them out. We are 7-8 kilometers away. So they have to be ejected only. If anything is wrong during launch itself, we find out, we know still will have to be launched. And the crew escape module will bring them down nearby in the sea, in Sriharikota. So that test we have conducted. So that is called pad abort test. Means on launch pad itself you have to abort the mission. Then the crew has to be evacuated. The module will still fly and come back and land in the sea. And one is when it is going up and that time something goes wrong. There also you have to take them out and again they will fall in the sea itself in Sriharikota. And anywhere else after launching, say first day or second day or third day something goes wrong. Say some fire happens. Then we have 90 minutes orbit. So in that 90 minutes you have to take them out to safer things. You have to land on them. So these are all the, because now once human beings are there, many things will come into picture. What we do on ground, on Earth. So that all will be that we use semiconductors that will have a role there. So here you can use all commercial device, everything. So it's not a big orbit, it's only 400 kilometer orbit. So and it is a short duration mission. So radiation and all this are not that important. So anything which we are using in our home, I can use it. So as much miniature as well, because our weight is increasing like anything. Right now itself we are 7 tons. It's a very high weight. That our launcher cannot carry that. If it increases slightly, we have to know, we don't know what we'll do. So, and then there are psychological risks due to radiation, environment, isolation, gravity. Like Sunita Williams, many people are saying that she has become frail and she is having psychological issues also like that. If you have prolonged stay, this is not prolonged but still, we are not used to this. They are trained. Our restaurant are just beginning to get trained. So they have never gone in space. So what will happen to them psychologically, physically, mentally, all these things we'll know only after they come back. So that is going to be another area where a lot of new things may happen. So whatever you can think of, wherever newer technologies, where semiconductor can play a role, whether it is habitat or many experiments are going to happen. So for that experiment also, newer and newer things, newer devices, it will happen. Finally, electric station. So it's like Gaganyaan only, one base module we call it, that will be launched, the base module. And around that, all other modules will get docked one by one. So to start from 2020, get over by 2030. These are all ambitious plans, like politicians like such plans. So we have our scientists have become now politicians. So they are giving such big plans. So it is easier said than done. So not easy. And India doesn't have technology. That is another big part that nobody is telling to hire of that. I may make big plans on paper, but reality you need the launch vehicle to take 20 ton into orbit. Our launch vehicle is at 4 ton. Now you can 4 to 20. How you can do leapfrog? In 55 years I have done 4 ton. You can imagine 4. But Basavaraja's friends are talking big things. And everybody is clapping. Politician will always talk big things. It is their duty because they have to show bigger picture. But when scientists start talking that way, you have to be careful. Because then some politician will ask us that you only told, like we told Gaganyaan 2022 started, 2019 Modi Sahab announced from on 15th August from that Lal Killa during that Independence Day. Then that in by 75th year 2022 India will be putting man in space. That is there we have one excuse that COVID came, that's why COVID or no COVID we would not have done it. Now we are telling 2026, that itself is a big, if we achieve that it will be a big achievement. These plans are big, very ambitious, and Kalam Sahib used to say you should have think big. So we are thinking big, but
This is that everyone is somebody else scientist take over.
so 20 tons, unless we improve, so now we have announced that we will make, Elon Musk said the 20 ton capability in SpaceX with the Falcon and all. So if we can do in private sector, why we are not able to do it for 55 years? That nobody's question. But this, if we have to do, we should have a launch vehicle. So we have announced launch vehicle also. But right now itself we are saying that it will take 8 years to make a 10 ton capacity launch vehicle.
So 20 ton is far.
So you can imagine. So 8 years right now we are telling you it may take 10, 15, who knows. Nobody gives you the technology. Problem is, okay, many other things like this foundry they are giving us. If they deny us foundry, we cannot build a foundry. It is impossible for India to do. Same way, this is also like that. Something we have to collaborate or we have to find out some alternative. It is not that it is not achievable, but with some other efforts and it will take its own time. But right now we are putting everything 2028. The Venus mission and many others. Of course, Chandrayaan 3 we have achieved. So again, lot of technologies we have used there. So whether it is satellite, propulsion module, lander, rover, everywhere, lot of semiconductor technology have been used. Because any planetary mission, it has to be miniaturized wherever possible. And then lot of testing also while testing also a lot of new technologies were used. So whether we tested it in lab, in crane, with drone, with helicopter, aircraft. And then what we did here in Ahmedabad, that landing site selection and then subsequent to that landing algorithm. when we are landing, what all processing we have to do. There is a hazard detection and avoidance processor. So the total algorithm was based on this. We have divided this. The landing area was like an airstrip of landing, 4 by 2.4. The land 2 times when we failed, it was 500 by 500 meter. Lander area is, this lander footprint is 4 meters square. So that 4 meters square will sit on a, we have divided this 4 by 2.4 kilometer section of 24 meters square. So 4 meters square will land on one of the 24 meters square section. So each section was categorized with this type of hazard map was created. So there were 3,901 sections of this total area. So for each section we have stored its feature, because initially we started with hazard map and we called it the feature map, so that we real time when we take camera images we can compare it with the feature map what we have stored inside that computer, and then try to see whether it is safe to land on that particular section. So this is how it worked, and finally when we landed like this, we started at 30 kilometers. So up to this time there is no role of any processing. 30 to 7.4 to 6.8. Legs are totally horizontal. From there, slowly, because the retro firing of the engine happens, so it becomes vertical. By this time, its velocity becomes from 6,000 kilometers per hour to 0, and it is at height of 800 meters. Then 800 to 150 straightway, it will come down like descent. And here now that processing and other things will start. So we take images, compare it, and see whether it is safe to land. If the feature matches and it is safe to land, we will land straightway. It will land. If it doesn't match, then we try to select an alternate section. So it moves horizontally and vertically both. So again here same processing. If it finds it is okay, it will land. If it doesn't find it is okay, means it is totally a different place. Means what we have envisaged or planned, it is not happened. Then it will, like a pilot lost with his aircraft, it will try to land on its own. So it is called emergency landing. So then it will take image of camera. So this is all 3D mode. From 3D it will shift to 2D mode and try to land wherever it finds it is homogeneous terrain. So on its own it takes decision. So without worrying about the feature mode which we restored. Because now it is on its own. So that day what happened was, it was here and then it appeared that it has done like this. It moved horizontally. Actually it moved 24 meters and came back and landed where we planned it at the original place. So it was a very good this thing. Image was there, video was there. So these are all what we did at Ahmedabad of this camera system. 7 cameras. This was a processor where we implemented that stored that hazard feature map. This is the radar. This is also crucial. Radar gives height of the turret. Japanese lander failed because it couldn't get the correct height. So while it was within some height, it told that you already reached the surface. So it slowed down that engine firing. So it consumed more fuel. And when it was still away, 2 kilometers away, all fuel was exhausted. So it just crash landed. So this again is the important. So all this was done. Landing site selection. Almost 7 years our team have worked here using all AI and many. We studied all moon images from different countries. Throughout these last 50 years, what all have been taken. They have been studied to find out the location where we should land. So there were site number 1 and site 2, site A and site B. So site A and B, so site A is in Ahmedabad, site B was in Bombay. It was 500 kilometers away. Means we started on 23rd August. If we would have missed that point, we would have started on 27th August. So instead of 23rd August, we would have landed on 27th. Then it would have been site B, which was 500 kilometers away from the site where we landed. So these two options were there. And now, next mission which will be planned jointly with JAXA, that is Japanese Space Agency. Our rover was this time 30 kg, that this rover will be sitting here. 350 kg, almost 12 times heavier. So this will be built by Japan. We have some sensors on that. And lander will be built by India. Launching will be by Japan. And the payload will be, we will also give payload, they will also have their own payload. And last mission was only one moon day. One moon day is 14 Earth days. After that it didn't work. We tried to revive it, but during night time that shoulder joints and all get disturbed. It get opened up. So go to almost minus 150, minus 200 degrees centigrade. So unless you qualified that soldering for that, we tried to do that, but it didn't work out. But this time it will be 7 moon days mission, means 100 Earth days. So all technology has to be qualified for that. Soldering and many other things. So it will be 350 kg over, and this is going to be, and now launching will be that 4 by 2.5 kilometer, instead of that it will be 100 meter by 100 meter. And landing will be with precision of 10 meter. So that much precise. Right now it was 500 meter. Where we landed and that accuracy was almost 500 meter. So this is going to be that change. And another mission is follow-up of Chandrayaan 3. This is a joint mission, earlier one, what I showed here. This still, the government has not approved it. It's still under approval. Both government, Japanese and this government has approved. That is, we will land and then one module will go up, bring back samples of soil, and then it will dock with. That's why this docking experiment we are doing tomorrow, day after tomorrow, is to as a precursor to that. So it will land, then one module will collect soil and other thing, it will go up, and then dock with the orbiter which is moving around moon, and then whole thing will come back. And out of that, one module where all the samples will be kept will only re-enter the Earth. Rest all will remain in Earth orbit and like this. It will land, and then one module will come up, it will dock with that one which is moving around moon, and then everything will come back, and then this module only will re-enter the Earth's atmosphere. So almost 4,000 degrees centigrade it has to enter with that high temperature it will encounter. So 2 missions are to be done, because again, launcher cannot launch all these things. So it will be in 2 steps. So 2 launch vehicles, one by one it will put these all these modules. So then Mars, this time Mangalyaan 2 will be Mars landing mission. It is easier to land on Mars compared to Moon, because there is an atmosphere on Mars. So I can use parachute for landing. But problem is, for Mars, any command I send, it takes 15 minutes to go. And then status will come after 15 minutes. So it will take 30 minutes for us to know what has happened. So that is the challenge in Mars. Otherwise landing is easy. So finally it will be as much difficult as Moon mission. And then future space tourism station, quantum engineering. That's something in 6 weeks develop. So right now we are working on this quantum link demonstration. So all this iteration will, with the setting up of these foundries, will help us speed up this. So right now, as I said, minimum it takes 1 to 2 years for us to do all these activities. Thank you. Large use of semiconductor, we are ending up with big satellites and big things. So you can imagine.
Thank you so much, sir. Thank you so much for your detailed presentation, sir. અને ખૂબ જ સરસ ટેકનિકલ ઇન્ફોર્મેશન ઇસરોનું વિશે પણ ઘણું બધું જાણવા મળ્યું એના ફ્યુચર પ્રોજેક્ટ વિશે અને અત્યાર સુધી જે પણ એક્ટિવિટી કરી આટલા વર્ષોથી તે આપણા માટે ગર્વની બાબત છે. ખૂબ ખૂબ ધન્યવાદ સર.
ઇસરોના નંબર 2 છે ચેરમેન પછીના. next January end he becomes chairman. So it will be ISRO main, the chill, the temperament, cool, simplicity. The main ISRO gives that culture basically. કે જે એન્ટર થાય છે એ બી 86 એન્ટર થાય અને જ્યારે એમને સો ધીસ ઇઝ વોટ ઇઝ રિયલ રિપ્રેઝન્ટેશન ઓફ ધ SEC and also ISRO. Okay, so we will give a big hand to
ખરેખર ખૂબ ગર્વની વાત છે આપણા સૌ માટે. બિઝનેસ એસોસિએશન ખૂબ જ ઉત્સાહ આપણા બધા માટે. હવે આપને શરૂઆતમાં વર્કશોપની શરૂઆતમાં એક કીટ આપેલ છે. કીટની અંદર ખૂબ જ સરસ ઇન્ફોર્મેશન છે સેમિકન્ડક્ટર વિશે, આપણી સેમિકન્ડક્ટરની પોલિસી વિશે, ઉપરાંત CED ની પણ અમુક યોજનાઓ વિશે માહિતી છે. તો આજે આપણે આજે સવારે વાત કરી કે પટિયાર સાહેબ ઉપસ્થિત છે જિલ્લા ઉદ્યોગ કેન્દ્ર અમદાવાદમાંથી. તો પટિયાર સાહેબને વિનંતી કરીશ કે શોર્ટમાં એમનું ડિટેલ ઇન્ટ્રોડક્શન, એમનું ત્યાં ઓફિસ છે અને એમની જે અમુક પોલિસી છે તો આપણને ખ્યાલ આવે તો આપણે જિલ્લા ઉદ્યોગ કેન્દ્રની મુલાકાત લઈને એનો ફાયદો લઈ શકીએ. કેમ કે ઉદ્યોગ ધંધો શરૂ કરવા જઈ રહ્યા છે, આપણે ઉદ્યોગ સાહસિક બનવા જઈ રહ્યા છે, તો સરકાર તરફથી પણ શું શું આપણને સ્કીમ ઉપલબ્ધ છે એ. તો આ ફાઇનલ સેશન છે, આના પછી આપણે હાઈટી માટે ફાઇનલ કરીશું. થેન્ક યુ સર.
થેન્ક યુ. જે રાજ્ય સરકારની વિવિધ સ્કીમો મેન્યુફેક્ચરિંગ સેક્ટરના ઉદ્યોગકારો માટે અસ્તિત્વમાં છે એના વિશે હું આપને સંક્ષિપ્તમાં માહિતી આપીશ. કોઈ પણ મેન્યુફેક્ચરિંગ સેક્ટરના ઉદ્યોગકાર એનો ધંધો સ્થાપવા માટે સૌ પ્રથમ એને જગ્યાની જરૂરિયાત પડે. તો જગ્યા માટે જો એના પાસે પોતાની જગ્યા અવેલેબલ ના હોય તો સ્ટેટ ગવર્મેન્ટ એને ભાડાની સબસિડી, ભાડાની જગ્યામાં એનું મેન્યુફેક્ચરિંગ યુનિટ સ્થાપી શકે એના માટે રેન્ટ આસિસ્ટન્ટની સ્કીમ છે સ્ટેટ ગવર્મેન્ટની. એ જે ભાડું પે કરે છે એના 65% અને મેક્સિમમ 1 લાખ રૂપિયા પ્રતિ વર્ષ એવું 5 વર્ષ માટે મળવાપાત્ર થાય છે. ત્યારબાદ પાવર કનેક્શન એટલે પાવર લોડની જરૂરિયાત ઊભી થાય. તો નવું પાવર કનેક્શન લેવા માટે, પાવર લોડમાં વધારો લેવા માટે અથવા તો પાવર કનેક્શન શિફ્ટ કરવા માટેની જરૂરિયાત ઊભી થાય તો એવા કિસ્સામાં એને જે ડિસ્કોમને પેમેન્ટ કરેલું હોય છે એના 35% અને 5 લાખ રૂપિયા મળવાપાત્ર થાય છે. ત્યાર પછી એને કોઈ પણ ફંડિંગની જરૂરિયાત રહે તો બેંક પાસેથી જે ફાઇનાન્શિયલ આસિસ્ટન્સ, ટર્મ લોન વગેરે મેળવે છે એના પર સ્ટેટ ગવર્મેન્ટ ફાઇનાન્શિયલ આસિસ્ટન્સ પ્રોવાઈડ કરે છે, જેમાં કેપિટલ સબસિડી, ઇન્ટરેસ્ટ સબસિડી, CGTMSE ફી, SGST સહાય વગેરે મળવાપાત્ર રહે છે. એમાં કેપિટલ સબસિડી જે 1 કરોડનું પ્લાન્ટ એન્ડ મશીનરીમાં ઇન્વેસ્ટમેન્ટ ધરાવતા એવા યુનિટને મળવાપાત્ર થાય છે. એમાં આપણે રાજ્ય સરકારે 3 ટાઈપની તાલુકા કેટેગરીઝ નક્કી કરેલી છે. જેમાં તાલુકા કેટેગરી એ એટલે કે જ્યાં ઓછું ડેવલપમેન્ટ, લેસ ડેવલપમેન્ટ હોય એવા તાલુકામાં યુનિટ સ્થાપવામાં આવે તો 25% અને મેક્સિમમ 35 લાખ રૂપિયા સુધીની કેપિટલ સહાય મળવાપાત્ર થાય છે. કેટેગરી 2માં તાલુકામાં 20% અને 30 લાખ રૂપિયાની સહાય મળવાપાત્ર થાય છે. અને કેટેગરી 3માં જ્યાં સારું ડેવલપમેન્ટ છે, ધારો કે અમદાવાદ તાલુકો હોય કે અમદાવાદ જિલ્લો હોય તો એવા જિલ્લામાં 10% અને મેક્સિમમ 10 લાખ રૂપિયાની કેપિટલ સહાય મળવાપાત્ર થાય છે. ત્યારબાદ ઇન્ટરેસ્ટ સબસિડી. ઇન્ટરેસ્ટ સબસિડીમાં પણ એ તાલુકા કેટેગરી પ્રમાણે ઓછું ડેવલપમેન્ટ છે ત્યાં 7%, તેના પછી 6% અને 5%, 5 વર્ષ, 6 વર્ષ અને 7 વર્ષ માટે મળવાપાત્ર થાય છે. જો ઉદ્યોગકારી એમની ટર્મ લોન CGTMSE સ્કીમ હેઠળ મંજૂર કરાવેલ હોય તો બેંકને એને નિશ્ચિત પ્રીમિયમ ભરવાનું રહે છે. એ પ્રીમિયમ 100% સ્ટેટ ગવર્મેન્ટ તરફથી એને રિમ્બર્સમેન્ટ મળવાપાત્ર રહે છે. ત્યાર પછી ઉદ્યોગકારને પ્રોડક્શન સ્ટાર્ટ કર્યા પછી એને પ્રોડક્ટની ક્વોલિટી માટે કોઈ સર્ટિફિકેશનની જરૂરિયાત હોય તો એ સર્ટિફિકેશન અને સર્ટિફિકેશન લેવા માટે કોઈ ઇક્વિપમેન્ટ લેવાની જરૂરિયાત હોય તો એના કોસ્ટિંગના 50% અને મેક્સિમમ 10 લાખ રૂપિયા સુધીની સહાય મળવાપાત્ર થાય છે. પછી SGST ની સ્કીમ છે, જે આપણું જે પ્રોડક્ટ સેલ કરીએ છીએ એ પ્રોડક્ટ સેલ કરો છો એમાંથી 80%, 90% અને 100% સુધીનો SGST રિમ્બર્સમેન્ટ આપ મેળવી શકો છો. એ પણ 10 વર્ષ માટેની એમાં મુદત મળે છે, જેના માટે આપણું ઇલિજિબલ ફિક્સ કેપિટલ ઇન્વેસ્ટમેન્ટ જે નક્કી કરેલું હોય, જે ડિસાઇડ કરે અમારી જિલ્લા ઉદ્યોગ કેન્દ્રની ટીમ દ્વારા, એ ઇલિજિબલ ફિક્સ કેપિટલ ઇન્વેસ્ટમેન્ટના 5%, 6.5% અને 7% પ્રતિ વર્ષ કેપ લિમિટ પ્રમાણે આપણે SGST ની સહાય મળવાપાત્ર રહે છે. ત્યાર પછી આપણે માર્કેટ ડેવલપમેન્ટ જરૂરિયાત ઊભી થાય, આપણી પ્રોડક્ટને ત્યાં કોઈ એક્ઝિબિશનમાં લઈ જવાની જરૂરિયાત ઊભી થાય, આપણે એક્ઝિબિશનમાં પાર્ટિસિપેટ કરવું પડે, તો એવા એક્ઝિબિશન માટે પણ સરકાર સહાય પૂરી પાડે છે. એમાં સ્ટેટ લેવલ, નેશનલ લેવલ, ઇન્ટરનેશનલ લેવલ, ઇન્ટરનેશનલ આઉટસાઇડ ઇન્ડિયા આ ટાઈપના એક્ઝિબિશન હોય છે, અને એવા મેક્સિમમ 8 એક્ઝિબિશન માટે 5 વર્ષ માટે સહાય મળે છે, જેમાં 50,000 રૂપિયાથી લઈને 5 લાખ રૂપિયા સુધીની સહાય મળવાપાત્ર થાય છે. પછી પેટન્ટ રજીસ્ટ્રેશન, કોઈએ એમનું પેટન્ટ ડેવલપ કરવાનું હોય અને એના માટે પેટન્ટ રજીસ્ટ્રેશન કરાવવું, પ્રોટોટાઇપ ડેવલપ કરવા માટે જે ખર્ચો કરવામાં આવે છે, જેમાં 75% સુધી 75% અને 25 લાખ રૂપિયા સુધીની સહાય મળવાપાત્ર રહે છે. ઇન્ફોર્મેશન ટેકનોલોજી એટલે કે આપનો જે યુનિટ છે એના માટે ICT ની સ્કીમ કે એના માટેના કોઈ કોમ્પ્યુટર હાર્ડવેર વસાવવાની આપને જરૂરિયાત ઊભી થાય તો એ કરેલ ખર્ચના 65% અને 5 લાખ રૂપિયા સુધીની સહાય મળે છે. ERP સોફ્ટવેર આપે લીધેલું હોય તો ERP સોફ્ટવેર માટે પણ 1 લાખ રૂપિયા સુધીની સહાય મળવાપાત્ર થાય છે. ત્યારબાદ કોઈ એવી શોર્ટ ફોર્મમાં ટેકનોલોજી જો કોઈ કંપની પાસેથી કે કોઈ એબ્રોડથી શોર્ટ ફોર્મમાં જે ઇન્ડિયામાં અવેલેબલ નથી એવી ટેકનોલોજી જો આપ લઈ આવો શોર્ટ ફોર્મમાં, તો ટેકનોલોજી મેળવવા માટે જે ખર્ચ કરો છો એના 65% અને 50 લાખ રૂપિયા સુધીની સહાય મળવાપાત્ર થાય છે. તે સિવાયની એનર્જી અને વોટર કન્ઝર્વેશનની સ્કીમ છે. જો એનર્જી અને વોટર કન્ઝર્વેશનના સેવિંગ માટેની આપ એનર્જી ઓડિટ કરાવો અને એમાં સેવિંગ માટેના ઇક્વિપમેન્ટ લગાવો તો એ ઇક્વિપમેન્ટ કોસ્ટના ખર્ચના મળવાપાત્ર થાય છે. એમાં 75% અને 50,000 તેમજ ઇક્વિપમેન્ટ કોસ્ટના 25% અને 20 લાખ રૂપિયા સુધીની સહાય મળવાપાત્ર રહે છે. પછી આપનું યુનિટ જો સ્ટોક માર્કેટમાં એટલે એક્સચેન્જમાં રજીસ્ટ્રેશન કરાવવું હોય SME એક્સચેન્જમાં, તો એ રજીસ્ટ્રેશન કોસ્ટના 50% અને 5 લાખ રૂપિયા સુધીની સહાય મળવાપાત્ર થાય છે. આ સિવાય પણ જિલ્લા ઉદ્યોગ કેન્દ્રની અંદર વિવિધ જેમ પોર્ટલ પર રજીસ્ટ્રેશન, CSPO રજીસ્ટ્રેશન, લુબ્રિકેટિંગ લાયસન્સ રજીસ્ટ્રેશન, ઉદ્યમ રજીસ્ટ્રેશન આ ટાઈપની સ્કીમો પણ ચાલતી હોય છે. અત્યારે આપને ટાઈમની અનુકૂળતા ઓછી હોય, જો આપ આ વિશે વધારે ડિટેલ્સ માહિતી મેળવવા માંગતા હોય તો જિલ્લા ઉદ્યોગ કેન્દ્ર અમદાવાદ, પહેલો માળ, બચત ભવન, દિલ્હી રોડ ખાતે સંપર્ક કરી શકો છો. થેન્ક યુ.
થેન્ક યુ વેરી મચ સર. સૌ પ્રથમ તો પ્રિન્સિપાલ સાહેબ જે અમારા ડાયરેક્ટર છે એમના સાનિધ્યમાં આજે પ્રોગ્રામ જે અમે ઓર્ગેનાઇઝ કર્યો છે સેમિકન્ડક્ટર, એ સિવાય આજના આપણા સ્પીકર તરીકે NM દેસાઈ સાહેબ, પિનાકીન ઠાકર સાહેબ અને સુધીર નાયક સાહેબ જે આજે ઉપસ્થિત રહેલ છે અને આપણને સેમિકન્ડક્ટર વિશે માહિતી આપી છે એ બદલ આપનો CED બદલ ખૂબ ખૂબ આભાર વ્યક્ત કરીએ છીએ. અને આજે જે ઉપસ્થિત જે પાર્ટિસિપન્ટ બધા ભાગ લીધો છે અને આપનો કિંમતી સમય ફાળવેલ છે એ બદલ CED વતી આપ ખૂબનો સૌનો આભાર વ્યક્ત કરું છું. અને હવે પછી આપણે હાઈટી લઈને આપણે બધા છૂટા પડીએ. હાઈટી માટે આપણે બધા છીએ.
થોડા પાછા આવી જજો વચ્ચેથી. મોટા ભાઈ બેસી જાઓ. મોટા ભાઈ બેસી થોડા સાઈડમાં
हाँ पहला आ जा ले पहला आ जा आ जा
બધા વચ્ચે વચાઈ જાઓ.
એટલે તું વિડીયો લે પછી ક્લિક કરે
ચાલ ચાલ
ત્યાંથી આમાં પેનિંગ મારી દે. વિડીયો છે
Thank you.